Students, are we live? Yes. Let's see if we are live. Hello, students. How are you all doing? Okay, I'm waiting for us to be live. Yes. Let me know in the chat box. Are we live? Yes, today we are doing a different type of classes, right? We are doing a different type of class. Okay. Yes, we are live. Hello. Good evening. Good evening. So you're going to see me very close today. That is what the new mode of teaching is, where you're going to see me very close. Yes, hello. Yes, I am audible. So, students, I'll be seeing your chats here. Okay, I'll be seeing your chats here. So, you can just keep typing and chatting. Okay, I mean, chatting with me. Okay, yes. So, are you all ready for body fluids in circulation? Yes or no? Can I see a lot of fire emojis in the chat box? Did you all watch yesterday's live? It was really so much fun, right? Yes, ready, steady. Okay. Good evening, good evening. So my eyes will be there sometimes so I can see the live, okay? I can see the chats. Students, share the link with your friends. This is not the number we are expecting. Come on. Share the link with your friends. Ask all the lazy people to come and join the class. Today, ma'am, they're planning to break my heart. Isn't it? Isn't it? I told you yesterday you cannot. Okay, this is not a pipe, student. This is the mic, okay? This is not a pipe, but this is a mic. Okay, yes, can you see? Mic and all I have, okay? Big person I've become. Mic and all I have. Yes, okay, fine. Okay, students, let's start the class. So, welcome to Vedantu NEET English. I am Miss Gopika, your biology educator. So, today we are going to do body fluids and circulation, where we have lot to talk about heart, body, blood vessels, and then about blood mainly, and also some topic about lymph. Okay, so yes, for few days this will be the mode of our classes, only for few days. After that we will be switching to boards. Okay, we will be writing again on the board. So I will share you the notes, do not worry. Okay, I'll share you the notes. My handwritten notes are there, and after that, if I can sit and write neatly, I will share that notes also, because your the handwriting might not come out really well. Okay, yes, are we ready? Right, yes, mic and all. Big person, yeah, big person. Baswaraj sir does not have mic, students, so very poor. Okay, please feel pity for him. Yes, okay. Yes, I will definitely come. Okay, so students, our class remains the same, right? Our class remains the same. So first you will have a trick your brain question from chemical coordination, because I could not do rapid fire that day because of lack of time, and because NMC gave us a heart attack that day, we could not do that. I mean, one news was come. So because of that, today we will be doing trick your brain question, and then we will do blood grouping, RH incompatibility, trick your brain again, and then we will do heart and the disorders. Okay, and let me tell you, students who are going to stay today, okay, students who are going to stay today in the class are the students who are dedicated to pass NEET 2024. I will tell you why. Student, the chapter is not easy. Let me be very frank with you. Chapter is not easy, and the amount we have to write, the amount you have to understand is a lot. So if you are not a true dedicated NEET aspirant, then I am sorry to say you will not even be here for 1 hour. Correct? Students who are there, or who will stay with me for 4 hours, 4.5 hours, 5 hours, of how much ever time I'm going to take to complete this chapter, those are the true NEET aspirants, and those are the ones who are going to be called or be in MBBS first year of their college. Okay, so let me see how many of you will be there throughout the class with the same dedication, and no doubt, write and keep it, you will definitely crack NEET 2024. Okay, yes, students, the first question: which of the following hormones, though synthesized? Okay, yes, it is a difficult chapter. Okay, it is a difficult chapter, students. By today, my handwriting is not going to be that great. Okay. So there's a student called Only Excuse. Okay, his name is Only Excuse. He's telling, start teaching, we don't have that time. Okay, so his name itself is like he's ready to make excuse, and he's telling me not to give motivation. Yes, students, what is this? Okay, no spammers here. Okay, spammers are not at all allowed in my class. So quickly answer this question. By then I will push away some people who are only here for making excuses and being rude. Okay, come on. Tell me the answer. Yes, come on, come on, come on. Tell me the answer. Very good, very good. Okay, what's the answer? Some of you are telling 1. Some of you are telling 4. Okay. Students, think properly. Which one of the following hormones, okay, which one of the following hormones is, though it is synthesized elsewhere, okay, even though it is synthesized elsewhere, it is stored and released by the master gland. Okay, some of you are right. So the answer is antidiuretic hormone, right? ADH. ADH. Right? You remember about ADH? We spoke in excretory system also. Antidiuretic hormone, right? So even though it is formed somewhere, the master gland is controlling it, right? Master gland is doing whatever job it has to get done with this antidiuretic hormone. Are we clear? Are we clear? Okay, no problem. Go and watch chemical coordination after this class. Next question. Fight, flight, reaction cause activation of dash. Very simple question. Very simple. Flight and fight. That means you remember the 3F. Remember the 3F? Flight, fight, fright. Right? Or flight, fight, fear. This 3Fs. When this activation has to happen, which is the one that gets activated? Students, there's only one answer. No one can go wrong in this. Come on. No one can go wrong in this. Very good, Subhashni, Rupa, YS, Sanvi. These are again my regular students. Sharath, regular. Vara Lakshmi, regular. Desiti, regular. I think I'm Laharika. Dr. Strange, Malar. Shena, yes. Smart Subhash, very good. Very smart. Okay, yes. So the answer is, students, the adrenal medulla, leading to the increased secretion of epinephrine or non-epinephrine, or adrenaline or non-adrenaline. Okay, now what is your score? Let me know what is your score. You got 4 marks in the previous question. Plus you got 4 marks. So your marks are 8 marks now. Okay, I think almost everyone got, right? Everyone got 8 marks. Okay, ready? Done? Okay, your name is still, I'll call you Mona. Mona. Nice. Okay. Yes. Okay, students, like normal, let's see how much does this chapter weightage. Okay. So, 2019, 2 questions. 2023 questions. 21, 2 questions. 22, 2 questions. 23, also 2 questions. 24, again, 3 questions. Do I have to explain why 3 questions? Do I have to explain why 3 questions? No, right? 3 questions because, again, chapters or syllabus is reduced. Because of that, we are expecting 1 more question to this, and because of that, we can expect how much? Let's do maths, right? I'm studying 4 table every day. 12 marks. Okay, 12 marks, right? Okay, now let me know all your scores in the class, and let me know how many of you are going to stay till the end of this chapter. That means whatever I'm writing, whatever I'm going to teach, right? You will be there till the end of the class. Come on, let me know in the chat box. You have to tell me and raise your hands. Okay? Yes. Very good. Smart Subhash. Digestion, not really because digestion is deleted, because the entire syllabus is reduced, no? Reduced, right? Earlier, it was 97 chapters. Now it has become 79 as a whole. So definitely, and again, bio 32. So because of that, here and there, questions will be added. And students from this chapter, no, we can make the entire NEET paper itself. Entire, zoology paper we can make from this, because the amount of questions, the amount of full twist is there. Okay, so students, this chapter, body fluids and circulation. Okay, I can see a lot of me in the chat box. Very good. So students, body fluid and circulation, we are going to learn first about blood. Okay, blood, and then we are going to talk about heart. Okay, heart, and then we are going to talk about blood vessels. With blood vessels, we are also going to talk about disorders. Okay, we are also going to talk about disorders. This is what the chapter is all about. Okay, blood is there, heart is there, blood vessel is there, disorder is there. Now, when I talk about all of this, right, when I talk about all of this, 1 second, yes. You need to understand that when we talk about blood, right, what is blood? It is a connective tissue, right? It is a separation of your connective tissue. Yes, No, not required, Ranjita, not required at all. You don't need to know digestion to know heart. Why? Heart does not even care about digestion. You eat food, you do not eat food, heart will still have pump the blood, right? So yes, students, this is a type of connective tissue. Now, all of you, if we might do, okay, we might do animal tissue. So that time you will learn more about this, right? Connective tissue is of three types. What are they? Loose connective tissue, right? Connective tissue. We have dense connective tissue. Okay, and last we have specialized tissue, or you can also call it as fluid tissue. Specialized connective tissue or fluid tissue. Now, under this specialized connective tissue, you have differentiation. Okay, there is lag. No lag, right? Something and all is happening in the group. This one, yeah, chats. You people know, just having fun of their life. Ma'am is not looking, so I will just sit and chit chat. Okay. Yes. Come on. Very good. Students, did you all like the session? Come on, we should be 100 likes now. It should already be 100 now. Come on, it's only 84. Make it 100. Yes, no lag. Okay. Yes. Students, this specialized connective tissue, okay, is divided, or you can again call it as fluid connective tissue. Okay. Fluid connective tissue. Okay. Fluid connective tissue. Okay, it is again divided into what? Blood and lymph. Simple. Okay, blood and lymph. So the specialized connective tissue or your fluid connective tissue is divided into blood and lymph. In that, what are we going to talk about? We are going to talk about blood. Okay, we are going to talk about blood. I know some of you will not be okay with this mode of teaching. Some of you might have a problem with the handwriting and all. I totally understand it. It is only for this week because JEE mains is happening and we have continuously marathons going in all the places. So that's the only reason. So for this week, you people have to adjust. Okay, next week onwards, we will be back to board. Okay, we will write on board beautifully with my beautiful handwriting. Okay, so only for this, students. And let me tell you, true aspirants do not care where the teacher is. Even if a teacher is sitting on the floor and teaching, they will sit and learn. Okay, so people who are complaining will sit and complain. You people don't bother. Okay, yes. Okay, so students, when we talk about blood, let's first divide blood, right? Let's just divide blood. Blood is divided into what and what, right? What and what? Okay, yes. Students, blood is divided, or let's write blood separately here. Okay, blood is separately divided. Okay, divided into what and what? Plasma, right? It is divided into plasma. Plasma contains, or the blood's plasma is around 55%. That means, what am I talking about? The blood, if you take blood, okay, or if you calculate the whole blood as a component, 55% of it is plasma. 55% of it is plasma. Then what is the rest? Blood corpuscles. What is it? Blood corpuscles. Okay, corpuscles. Now, since I told you this is 55%, this will be 45%. Basic maths. Yes, very good. Okay. Yes, blood has plasma, which takes up around 55%. Then we have blood corpuscles, which take up around 45%. Okay, 45%. Now we will write it here. Okay, so students, let's talk about plasma first. What do we know about plasma as of now? We know that plasma is yellowish. It is yellowish in color. Okay, yellowish in color. Clear to all of you? Okay, it is yellowish in color, first thing. Then it is the fluid part. It is the fluid part of the blood. Okay, fluid part of the blood. That means, what does it mean? This fluid part, the other part which is there, that means we have blood, right? In that 55%, this becomes the fluid part. The rest becomes what? The cell part, right? The thick, the solid part, right? The semi-solid, the solid part of it. Okay, so this becomes the fluid part of the blood. Okay, now fluid part of the blood is not just like that. Okay, it is the fluid part because it contains around 90 to 92% of H2. Students, open your NCERT and see every single line is NCERT. Every single line is NCERT. Okay, and it also contains some proteins. So some proteins are there, some formed elements are there. Okay, proteins are there, minerals are there, formed elements are there. Okay, all these things are there. Okay, all these things are there. Students, my throat is not completely fine, so there might be sometime, crack voice coming. Okay, don't get scared. Don't be like, oh, who is this another person talking in the live? It's my voice, my own voice modulating by itself. Okay, that is recovery. I haven't given time for recovery. My throat is like, oh, I want to recover. No, I'm like, no, you don't have time to recover, right? So crack voice might come sometime. Yes. So let's get back. 90 to 92% is water. Then the rest is protein. Okay, some portion is protein. In proteins there is mainly three parts. Okay, three types of proteins are there which are very, 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 very prominent. Okay, three types of proteins are there which are very, very prominent. Okay, first one is fibrinogen. Now, all my students have studied it in 10th, I guess, or 8th also, right? Fibrinogen. Very good. You people have already put the answer. Globulins, okay, and albumins. These three are the proteins which are present in plasma. And these three are just not present like that. They have some job. They are here for some job, right? Everything that is present in the body has a job. They have to fulfill their job. Okay. Now, students, as the term fibrinogen comes, what do you remember from fibrinogen? Tell me, all of you in the chat box, what do you know about fibrinogen? Okay. What do you know from fibrinogen? Clotting, correct. Fibrin, right? Thrombokinase. Last is fibrin, insoluble, then mesh formation, right? We will learn about it, but it is mainly for clotting, right? It is mainly for clotting. Got it? All of you? Mainly for clotting. Now, when I talk about globulins, you should understand, okay, all of you are writing notes with me or not? Yes or no? I'm not worried if the chats are not moving also very fast. Okay, when I ask a question, please answer. Otherwise, please continue writing. Okay, please make your own notes. So you will not have to wait, okay, till the last minute. And students, short notes are very important because when you're doing your last minute revision, that means imagine in the month of April, now we are almost coming to an end of Jan. In the month of April, you will not be able to sit and watch all the 4 hours video. That time your short notes are going to help, right? So please do write your notes with me. Okay, with me. Yes, very good. Writing, ma'am. Good job. Okay, globulins, we have alpha, beta, and gamma. Okay, alpha, beta, and gamma globulins. Now, all of these people, okay, all of these people are doing defense. What are they doing? Defense mechanism. Some can be carrier protein, some can be doing the defense mechanism, but all these three people are doing defense mechanism. Clear to all of you? Easy. Okay. Now, when I talk about albumins, this also we discussed in our excretion chapter. I use some term called as BCOP. That means blood colloidal osmotic pressure, right? That means what is happening, students? Blood was coming in, right? Blood was coming into the glomerular filtrate. But this albumin, right? This albumin was restricting or blocking this. That means for the balance of the osmotic pressure, we needed albumin. So, BCOP or your blood, right? Blood osmotic, okay, blood colloidal, sorry. Okay. Okay, blood colloidal, yes. Blood colloidal osmotic pressure. Yes, got it. Blood colloidal osmotic pressure. So, can I say that it is mainly for osmotic pressure? Yes, simple. Right? Osmoregulation, osmotic pressure. This is what these people are doing. So, whatever is in our body is doing something or the other. Okay, then as humans, we also should do some job. Right? We also should always do some job. Students, other than that, they also have some minerals like calcium, Na, and all that is present. Okay, some minerals are also present. What are they? Many minerals are given in your NCERT. Please take a note of that. Mg, Ca, potassium, all these minerals also are present. Okay, did you all like this session? Did you all mark your attendance? Yes or no? Quickly tell me. Quickly tell me. Okay. Yes, very good, very good. I can see a lot of new students. Yes, very good. Mg, HCO3, right? Ca, Na, all these people are there. Yes? Okay, good. Okay, students, yes. So, this albumin is clear. All this is clear. Proteins are clear, right? Clotting, globulins, alpha, beta, gamma, all these three are using for defense mechanism. Then we have albumins, which is going to do osmotic pressure. Okay, it's going to do osmotic pressure. Now, students, please make a note of this. Please make a note of this. Now, if the plasma, okay, if the plasma does not, okay, plasma with no protein or some protein or without clotting factor, okay, so plasma without clotting factor. Now you all tell me which is the clotting factor. Plasma without clotting factor is called as serum. Plasma without clotting factor is called as serum. Now you tell me which is the clotting factor. All of you tell me which is the clotting factor. No one told? Yes, very good. Serum is the answer. Correct. Now, plasma without the clotting factor means who is the only protein which is responsible for clotting? Fibrinogen, right? So, plasma without fibrinogen. In other words, I can write it. Plasma without fibrinogen. Are we 100 likes? Did we get 100 likes? Yes or no? Let me see. I told the students yesterday 200 likes, okay? And I heard Leharika telling, ma'am is too kind. It's okay if we don't like also, ma'am will come for the class. People are taking me for granted. I'm very strict. Yes or no? Okay? Yes or no? Yes, very good. Only 100. If I tell 100 they will make, okay? They will not even make one extra also. Good kids. I have the best kids. Okay. Oh, 101 it seems. Okay, fine. Okay, students. So, serum means plasma without clotting factor and clotting factor is fibrinogen. Is this clear? Easy peasy. Okay. Now, I told you about blood corpuscles, right? We spoke about plasma. That's all is about plasma. Nothing else is there about plasma. Everything is mentioned about plasma to you. Okay, for all of you. Now, when we talk about blood corpuscles, what is blood corpuscles? Only the word is little, fancy, students, but you know this. Okay, blood corpuscles, right? Means what? Simple. RBC, WBC, and platelets. Simple. Platelets. That's all. Okay, that's all. Right? Yes, I am strict. Why are you people laughing? Okay. full wrong information and all. Yes. Okay. So RBC, WBC and platelets. Now all of you tell me the scientific names. The other names. Tell me the other names of this. Yes. RBC is also called as erythrocyte. Correct? RBC is also called as erythrocyte. Okay. WBC is also called as leukocytes. And platelets is also called as thrombocytes. Okay. Students, all of you, after writing the notes, if you are on Instagram, you can take a screenshot of your notes and tag me on the notes. Okay. Gopika Biology. Gopika_biology. Okay. Yes. So, erythrocyte, leukocytes, thrombocytes. Very good. Okay, leukocytes, you can write C or K, students. We are British, American English we can use. Okay, erythrocyte, leukocyte and thrombocyte. So, RBC, WBC and platelets. Okay, that is all about your blood corpuscles. Then we will go in detail for each of it. But otherwise, no problem. If you don't have Insta, please don't download telling that, oh, Gopika ma'am told me to tag, so I have to download. Okay? No, please don't. Okay, only if you're there, please do it. Yes. Okay, students, look at the composition of the blood. Composition of the blood, you have plasma around 55%, then you have white blood cells, again white blood cells and platelets around 4%, then you have RBCs which is around 41%. Okay, RBCs which is around 41%. Clear or not? So the yellow color portion, right, the yellowish portion that you're seeing here is your plasma. This is your plasma, right? And then the oval, this oval shaped structure which you're seeing, which looks like a it is called as actually dumbbell shaped. Okay, dumbbell shaped, because it will look something like this. If you actually see it, it will look like this. Okay, dumbbell shaped. Then we say oval, right? Oval shaped, like this. Okay, like this. Yeah, all these things we say for our RBCs. Then we have, like, you know, like a COVID virus, we have some people going around, no, those are the platelets. And then we have some white cottony structures which are called your white blood cells. White, you can just look at it and understand. Yes or no? Okay, fine. Now let's understand about RBC. These are all simple things, so we'll not waste our time a lot on this. Okay, RBCs are also called as erythrocytes. Okay, RBC is also called as erythrocytes. Now, what is the number? How much do we have? We have somewhere between 5 to 5.5 million, okay, million per, okay, million per mm cube of blood. This is how much RBC or red blood cells that we have in our body. Okay, that we have in our body. 5 to 5.5 million per mm cube of blood. Okay, mm cube of blood. Okay, then students, what is the main thing about RBC? It is mainly most abundant. Okay, it is most abundant. Got it, all of you? Most abundant. Just looking at the number, you know, no, it is the most abundant. And where are they formed? They are formed in the bone marrow. Bone marrow. Okay, question to all of you. Tell me the lifespan. Tell me the lifespan of RBC. That means, when will it khatam? when will it die, right? When will it has end of its life? Birth to death between. That is called the lifespan. No? So what is the lifespan? Okay, what's the lifespan? Okay. Very good, Rupa. Very good. Very good. Correct. Correct. Okay. So, students, it is formed in the bone marrow. So, the formation of RBC is called as okay, erythropoiesis. Erythropoiesis. Now, all my students know this word erythropoiesis if they have attended my class. If they have attended my chemical coordination class, chemical coordination integration class, my students will tell me where is this erythropoiesis happening with the help of an erythropoietin protein. Let me see who is the answer, who is telling the answer. Yes, erythropoiesis means formation of RBC. Okay, formation of RBC. Simple. Formation of RBC happening in the bone marrow. Process called erythropoiesis. With the help of a protein which will stimulate erythropoiesis to happen is called as erythropoietin. Come on. Let me see. Adrenal gland. No, not adrenal gland. Thank you so much, Anupam. Thank you so much. All of them who are here are the people, right? Adrenal cortex. Why all of you are telling adrenal? Can you tell me the exact one cell, students? One cell, which is also an excretion. Okay, erythropoietin will stimulate. Okay, stimulate. Erythropoietin is the protein. Students, this one, remember? JG cells. Can you remember, all of you? JG cells of the kidney. JG cells of the kidney. Remember? Yes, very good. Now it clicked for everything. Juxtaglomerular cells, that means the modification of your afferent arterioles, which is going to your glomerulus, right? Those cells, those afferent arterioles, few cells gets modified to form JG cells. That JG cells will form a protein called as erythropoietin, which will stimulate a process called as erythropoiesis. Yes or no? Yes or no? Okay. Yeah, even I have written per mm cube of blood. Okay, it is written 5 million to 5.5 millions of RBC mm cube of blood. Okay, yes, students. So this process is called erythropoiesis. Now, they are okay. Who are this RBC? Okay, RBCs are devoid of protein. Okay, they are devoid of devoid of nucleus. Telling protein, I forgot. Devoid of nucleus. That means they are enucleated. Okay, they are devoid of nucleus. And how is their structure? They are like this, right? I told you, dumbbell shaped. Okay, dumbbell shaped structure. Dumbbell shaped structure. Okay, we can also call it as biconcave. Biconcave. Yes, all of you are with me? Yes, all of you are with me? Come on, let me know. Okay, yes. Students, mostly they are biconcave. In some animals like camel and all that, they are circular. Okay, they are circular. Clear? They are circular in some animals like camel. Those are modifications. Those are modifications. Okay, if I'm writing here, it is C, no? Yes, it is C. Yes, okay. Fine. Now, biconcave. Okay, clear? Now they have a pigment. They have person called as hemoglobin. Okay, yeah, hemoglobin, which is the main reason for providing the iron, for providing the color to RBC. Yes or no? Yes or no? We can also write it as HB, right? Hemoglobin. Okay, right? I've written globin, because of just telling about this one. Hemoglobin, or we can also write it as HB. Now this one, what does it do? It also acts like a respiratory. It also acts like a respiratory pigment. Now, all of you tell me, what is the meaning of respiratory pigment? The word itself, what is it talking about? Respiration. That means it is capable or it is able to, right? It is capable or it is able to do respiration, or it is able to do what? Exchange of gases. It is able to carry oxygen, remove carbon dioxide. It is able to do that kind of a respiration. Yes or no? Yes or no? Correct. Right. Okay, so it is able to, or it is helping in exchange of gases. It is doing help in exchange of gases. Yes. Lot of hearts are coming instead of telling the answer. Yes. Good job. Exchange of gases. Okay, this much clear? Easy. Hemoglobin, biconcave in nature. It is present in humans. There are some animals which have circular RBCs, that is in camels. Okay, and this RBC has a pigment, or it has a protein, iron containing protein called as hemoglobin, which is also known as HB, that helps in exchange of gases. So it is also known as a respiratory pigment. Clear? Yes. Okay, fine. Okay, now students, understand a healthy person. What is a healthy person? A person who does not have any kind of very crucial disease. Okay, no, common cold and all that is normal. Fever also is normal. But otherwise, a normal healthy person will have around 12 to 16 grams or GMS of hemoglobin in how many? In 100 ml of blood. That means if I take 100 ml of blood, Okay, I will get 12 to 16 GMS of hemoglobin. 12 to 16 grams of hemoglobin. Got it, all of you? Yes. Okay, a normal person, a healthy person, an ideal person will have around 12 to 16. Okay, hemoglobin. Clear or not? Now, all of you told me that RBC's lifespan is 120 days. Okay, most of you otherwise also told the answer, but anyways, we'll write it here. RBC's lifespan. Okay, RBC's lifespan is around 120 days. Okay, 120 days. Okay, now after 120 days, that means where do they go and die, right? Where do they go? Like we bury people, right? So it is the graveyard. The graveyard of your RBC is called spleen. Spleen is called the graveyard of RBC. Can you all see? Can you all see? Okay. Yes, I have moved. Can you all see now? Yes, very good. Destroyed in the spleen after 120 days. Okay. Graveyard is known as your spleen. Okay. I hope all of you joined the victory mock test. Okay. We have extended because we were feeling bad that, you know, what if some of the students did not watch sir's video? What if they are not able to get the mock test? Then we will feel bad, no? So that's why we have extended it up to 28. Okay. The link is being pinned on the comments. Okay, it is linked, pinned on the description. So just click on the link, enroll right now, and just keep yourself safe. Okay, otherwise you'll have to pay money. Yes? Okay. Fine. So that is all about RBC, right? Yes or no? Is there anything that we have missed from RBC? No, we have not missed anything from RBC. I have added extra slides in case something comes suddenly. Okay. Yes. Yes, enrolled. Okay. Students, any problem with the enrollment, I have shared an email ID on my Telegram as well as on Vedantu NEET English Telegram. Okay. We have shared an email ID. Okay. So you can drop a message or you can drop a mail to that email and you can send your phone number. They will contact you and rectify whatever errors have been happening. Okay, because understand, technology is there, but then definitely if 1,000 people are trying to enroll at one time, server will get down, right? Server will get down, even though it is a robotic system or everything. Okay, it will shut down, right? That is the reason. If there is any issue, quickly join our Vedantu NEET English Telegram and type a mail to that email ID and tell this is the issue I'm facing. I'm not getting OTP or OTP is coming late whatsoever, and they will rectify it. Okay, students, WBC is also called as leukocytes. Right? Leukocytes. Yes or no? Leukocytes you can write. K also no problem. C also you can write. Now this WBC is called as leukocytes, and the normal count. What is the normal count of RBC? Was 5 to 5.5 million. Here you see what's less, very less. 6,000 to 8,000 only. 6,000 to 8,000 only. Okay. How many? Per mm cube, okay, per mm cube of blood. Got it, all of you? Normal count is 6,000 to 8,000 per mm cube of blood. Okay, that is why we told RBC is the most abundant. RBC is the most abundant. Okay, it is colorless. No pigments are there. Colorless, right? That is why it is always depicted and shown in white color. Right? It is colorless. Okay, why is it colorless? Why is it colorless? Simple. Due to the lack of HB. Due to the lack of HB. Yes or no? Okay, very good. Yes. Now, they are nucleated. Okay, they are different from RBC in many ways. They are nucleated. Okay, they are nucleated. That means they have nucleus. Okay. And they are less in number. It is understood, no? 6,000 is where? 5 million is where? Right? 6,000 is where? 5 million is where? Okay. Again, students, this one's also formation is happening in bone marrow. Formation in bone marrow. No difference in the formation. Formation is in the bone marrow. Clear or not? And when formation happens, what is the term we can use? What did we use there? Erythropoiesis. Then what will we use here? What will we use here? Tell me. Leukopoiesis. Simple. Right? Leukopoiesis. There we used erythropoiesis. So here we will use leukopoiesis. Okay? Leukopoiesis. Yes. Are you all writing? Okay? Easy. So far it's easy, students. Don't worry. Okay? Now it's here and all. It's easy peasy. When we reach heart only, little pain will happen here. Right? Pain will happen. Okay, leukopoiesis. Very good. Okay. Now, students, if there is wait. I understood. I just remembered we have to deal with one more thing. Students, here only write it off. Okay, here there's no place. Okay, here let's write. Students, RBC. Okay, all of you write this. Okay, RBC. Okay, if there is a deficiency. And if there is an increase. What am I trying to say? That means RBC is less, 5.5 million or 5 million, lesser than that. It is 2 million, 3 million. What will happen? That condition, okay, that condition is called as, are you all right, able to see now the slide, right? Erythrocytopenia. Erythrocytopenia, right? Okay, very good. Erythrocytopenia. Okay, students, erythropoietin is the protein that stimulates. Okay, do not get it confused. Dr. Strange, erythrocytopenia. Whenever the word penia comes, that means deficiency. Okay, now when increase come, that means what is happening? Increase is happening. Okay, polycythemia. Okay, sorry, 1 second. Polycythemia. Yes. Polycythemia. Got it? Whenever there is a deficiency, it is called as erythrocytopenia. Whenever there is an increase, it's called as polycythemia. Okay? Right? Yes, we say anemia also, no? Okay, same thing here also, students. WBC also. If there is a deficiency, okay, if there is a deficiency and if there is an increase, what will be deficiency called as? Okay, what is deficiency called as? Okay, we have a speedometer in the class. His name is Krishna. Okay, speedometer is checking the speed. He thought that we were doing students, now this is not your time to do like, oh yeah, WBC, students, leukocytes. Okay, 600. If you do that, what's the point? This is your time where you can study, right? Till Jan end, at least you can calmly prepare. After that, March and April and all will be rushing, right? Jan and Feb, you can aram se learn the chapter. Okay, speedometer done. If you have checked the speed, please leave the class. Yes, speedometer has gone because he checked the speed. Okay, yes, fine. Okay, fine. Students, so deficiency means what? Deficiency means leukopenia. You people are faster. Very good. Okay, leukopenia. Okay, increase means what? What is increase? So it is called leukocytosis. Leukopenia and leukocytosis. Spammers does not know that Gopika ma'am will roast them, right? Yes or no, students? Roast is so sure, no? If you're joining my class as a spammer, roast is definite. How can I leave you just like that, no? When you come and make I don't want be there in the class. I don't want to remove him also. Right? I don't want to remove also. Okay. Leukocytosis or leukopenia. Clear? Okay, fine. Let's go. Now, students, understand. Okay, understand. Wait. 1 second. 1 second. Yes. So, students, in WBC, when we talk about WBC, Where is it, yaar? Yes. Okay. So students, when we talk about leukopenia, leukocytosis, after that we have to understand that WBC has two types. WBC can be of two types. Okay. First of all, understand WBC, we have 5 types. Okay. 5 types we have. Five types we have. What is it? Monocyte, lymphocyte, neutrophil, eosinophils, basophils. 5 types of WBC. Once again, I'm telling monocytes, lymphocytes, okay, neutrophil, eosinophils, basophils. Okay, this many types we have. Okay, this many types we have. Okay, then, yes. See, leukemia means if there is an increase and that increase forms a tumor, that will form leukemia. Cancerous. Okay, when WBC accumulates, increased number happen, and then they will start forming a tumor. Remember about the tumors? They will form a tumor that is called as leukemia. Who asked me the doubts? Clear? Yes? Yeah, today to lot of spammers, yeah? From where have everyone come? Can't believe this many spammers. Today too much work they're giving me. Today why everyone, oh yeah, everyone half day, no? That's why. Chalo, we'll go to some class and disturb. Okay, WBC, we have agranulocytes, and granulocytes. Simple students, from the name itself, you know, granulocytes. Okay, agranulocytes means they do not have granules. Okay, they do not have granules. Okay, now if I draw one, okay, imagine I'm drawing this. Okay, can you all see? Now here a kidney shaped cells are there, normal dots are there. Okay, normal dots are there. Here also I'm drawing one. Okay, I'm drawing one. Okay, yes. Now it looks like a crab, but it's not a crab. It is the lobes. Okay, lobes. Okay, here we will put some dots. Okay, these dots or these are called as granules. I'll show you the image, do not worry. So, the ones with granules are called as granulocytes and one without granules is called as agranulocytes. Clear or not? Okay, agranulocytes. Clear or not? Somehow they have got to. Yeah, true. Okay, yes. So students, agranulocytes, we have two types, monocyte and lymphocytes. Okay, monocytes and lymphocytes are the two types of agranulocytes. Okay, I'm writing here agranulocytes. Agranulocytes are two types. Okay, we have monocytes and lymphocytes. Lymphocytes also you people have studied, remember? Right, we have studied human health. Then, when we talk about granulocytes, we have three types. Okay, neutrophil. Students, I have added as many images as possible in this class, so it looks more like, you know, like a visual appearance is good. Okay, so I have put lot of, you know, gifs and everything to make it look very interesting. Your class to look interesting. Yes or no? Yes. Okay. Yes. Okay, so agranulocytes, monocytes, lymphocytes, granulocytes, neutrophils, basophils, and eosinophils. Okay, done, dusted. Yes. Okay, now let's understand each of it like in detail. Okay, each of it in detail. Okay. Today they give me too much work, students. Too much work. There are some people who are so jobless. They have come. Oh, let's disturb them. Let's disturb their class. Let she not take a good biology class. Right? That is what they're thinking. Okay, let's start granulocytes. Okay, granulocytes. Now, when I talk about granulocytes, it is, students understand, the survival rate. That means now we understood that WBC or RBC will be for 120 days. Now, granulocytes can only stay for 4 to 8 hours. And in some cases, okay, in some cases, they can go 4 to 5 days. That is when it is inside the tissue. Okay, if it is outside, and it is just moving through the blood vessels, then it will only be there for 4 to 8 hours. But imagine they had to attack, something entered the tissue, they had to attack inside, that time they can go up to 4 to 5 days. Clear or not? Okay. Clear? Yes. Okay, fine. Now this granulocytes, I already told you the division. It is divided into, first, neutrophils. First, we'll write the points for neutrophils and then go further. Okay, neutrophils. Okay, let's try to understand what are the things in neutrophils. Yes. Students, speed is okay, right? Speed is okay because this is also new setup for me. Maybe I'm a little slow because board is more comfortable. But in case if you're feeling that I'm very slow, please let me know in the chats. Okay, you can let me know, ma'am. Can you please speed up a little? I will definitely speed up. Okay, so this is a neutrophil. Okay, this is a neutrophil, right? Yes. This one has, it looks like a crab, no? But those are the lobes. Okay, those are the lobes. So it is multi-lobed. Okay, it is multi-lobed. Okay. Yes. Okay, fine. It is multi-lobed and it contains, the neutrophils are around 60 to 65%. That means it is the highest number. Okay. So when you compare the entire WBC, 60 to 65% is neutrophils. Okay. 60 to 65% is neutrophils. Okay. And students, these names also, this neutrophils, basophils, eosinophils did not just come like that. It came mainly because of the way it gets stained. Now, neutrophils, what do you understand? Okay, neutrophils, what do you understand? It is neutral. That means you can dye it with, what do you tell? It looks like a crab, no, Vijay? Okay, students, you're not supposed to tease my diagrams. I have already told you before. Okay, so yes. So students, it means that even it can be stained both with acidic and basic stain. Okay, it can be stained both with acidic and basic stain. It can be stained with both acidic and basic stain. Yes, got it? Very good. Neutral, right? Neutral. Okay, now this is how the name came. Okay, and what is this job of phagocyte? Sorry, what is, I almost told that thing. What is the job of a neutrophil? It is phagocytic in nature. Okay, phagocytic in nature. That means, students, this one is the first line of defense. So imagine I am the foreign particle. I am the allergen. I got inside your body. Who will fight? Neutrophil will fight. Neutrophil will be the first person to go and be like, yes, you have come in. I'm ready to fight with you. So the first defense is by the neutrophils. Yes or no? Clear or not? Okay, first defense is by the neutrophil. Okay, now this neutrophil is clear. Now let's understand basophils. Okay, let's understand basophils. Yes. So next one is basophils. Okay. Now basophils, first I will draw it. This is how the lobe looks. Okay, it is an S-shaped lobe. Okay, S-shaped lobe. Yes. First thing, is it multi-lobed, bilobed? What is it? It has an S-shaped lobe. Okay, S-shaped lobe. Now next we will write the number. It is around 0.5 to 1%. How much? 0.5 to 1%. That's all. That's all. Very less. 0.1 to 5%. Okay. Now, from the name, what do you understand? It can be stained by what? Okay, it can be stained by what? Tell me. They're coming in my own student's name only. Wah. Wah, wah, wah. Okay, 1 second, students. I have to tell one person to manage this channel by themselves. Okay, 1 second. Let me tell someone. Yes, 1 second. These are some problems, students, with, what to do. We can't do anything, right? Yes. Okay. So this basophils are basic dyes. That means they can be stained with basic dyes. Clear? Okay. Now, what do these people do? Basophils are the first people to cause any inflammation. Now, the question comes, what is secreted by mast cells which will actually cause any kind of inflammation in your body or show an allergic reaction? All of you studied human health with me. Tell me what is secreted, right? What is secreted? Tell me. Yes, very good. Histamine, right? Histamine. Okay, once, she's calling me. Yes, I've told our manager, please check that many students. Spammers come only for one reason, because either they know that the class is too good and they have to disturb the class. When such messages come, it will disturb the crowd. That is the main reason they come. Okay, so we have one as a class, me as a teacher, you as a student. We are a group now. We are like one gang now, right? So we have one. That is the reason they are coming. Okay, otherwise why will they come, students? See, imagine 2 live watching is there. Why will they come and spam there? You tell me. Class is not good, very boring. Why will they come and spam there? Right? So when the class is good, spammers will come. So it shows, no? Right? Yes, very good, very good. Histamine is the first thing released by the mast cells, telling that, okay, now it's time. This girl has eaten some walnut. Now let's do allergy. So that is also done by these people. So inflammation can be caused because they secrete 3 things. Okay, they secrete 3 things. Okay, serotonin. Okay, serotonin. They release histamine. Okay, histamine, and they release heparin. They release heparin. Okay. Okay, no problem, Shivakumar. Continue from here. So, students, what are these people going to do? Serotonin is a vasoconstrictor. We have learned about vasodilator. Who? Histamine is a vasodilator. That's why the blood moves and you become fully red, you know. So, this is a vasoconstrictor. Okay, constrictor, yes. Then histamine, vasodilator. That's the reason we are able to see, no, any kind of like, what is that, any kind of allergic reaction is seen because of that, right? And heparin is an anticoagulant. This also we studied. Remember, students, dialysis, heparin will be injected. Remember, heparin will be injected before the dialysis, and then anti-heparin will be injected. So it is an anticoagulant. Yes, done, dusted. Then we have eosinophils. Shall I write eosinophils here only? Yes, I have a lot of space to write eosinophils. Okay. Yes, let's write eosinophils also. Okay. Yes. So students, eosinophils are also known as acidophils. It's also known as acidophils. Okay. Now, what is their number? Anyone knows the number? How much percentage is given in your NCERT? 2 to 3%. 2 to 3%. And what are they? How are they? They have a lobe which is like this. Headphones. It looks like a headphones, right? Like this. 2 headphones, right? So it is bilobed, or we can say headphone shaped. headphone shaped lobes. Headphone shaped lobes. Okay. 1 second, students. 1 second. Yeah. When I like you so much that I have to throw you out of the class. Okay. Yes. So it is a headphone shaped lobes. Okay. 2 to 3%. Okay. And then what, students? They are also called as acidophils. That means what? It can be stained by acid. It can be stained by acid dyes. Simple. It can be stained by acid dyes. Now, what do these eosinophils do? So, imagine allergen is coming. Okay, some kind of dust is coming. Okay. As soon as allergens are coming, students, this eosinophils will be the people to suppress the allergy. Okay, so in my body, what has happened? Eosinophils concentration has reduced. That is the reason why I am very, very dust allergic. That means eosinophils are become weak, or the number has reduced. So these people actually suppress the allergy. Got me? Suppress the allergy. Okay. Yes. Okay. Done. Okay. Yes. Is this clear? Any doubts so far? Easy. So granulocyte, students, all of this have granules. Okay. All of this have those dotted structure. Okay. All of this have granules. Now let's see. Okay. Look here. You have leukocytes, you have granulocytes and agranulocytes. In agranulocytes, what are there? Monocytes are there. Right? Monocytes are there. Lymphocytes are there. Okay. Monocytes are there. Lymphocytes are there. Okay, monocytes are there and lymphocytes are there. Okay, so in 1 minute. Please write that box by then, all of you. Please write that box by then. Okay, with me. Yes, wrote all of you? Wrote? Let's just charge this people. Yes. No, I'm here. I did not disappear. Okay. Yes. Students, so monocytes and lymphocytes. These are agranulocytes. Now look at the percentage, 2 to 3%. Now which is the one which is least? Basophils are the ones which are least. Okay. Basophils are the ones which are least. Now look here, all of you. I sent actually one YouTube video on my Telegram, which was showing how this WBCs are actually engulfing. Okay, that phagocytosis, how do they do? Now, this is the foreign particle. Okay, this is the foreign particle. Phagocytes will go like this and eat this. Okay, can you see? Can you see the movement? Yes or no? Can you see? Yes. Yes, okay. Good job. Okay, students, here we'll also write about our agranulocytes. Okay, we will write about our agranulocytes. Okay, what do agranulocytes are? Monocyte. Students, monocyte, what is the speciality is that they have a kidney-shaped lobe. Like they're like this. This is how the lobes look. Kidney-shaped. Okay, kidney-shaped. So first I'll write kidney-shaped. Yes. Got it? Or you can also say it horseshoe-shaped. So in some books, different names they'll give. Horseshoe-shaped. Okay. These are monocytes. That means they do not have granules in them. They do not have granules in them. Okay. Yes. Yes. And students, very, very important. They are largest in size. So the question comes to all of you. All of you look here and answer me. Which is the one that is largest in number and which is the one which is largest in size? Okay, two answers. Size and number. Okay, just write size, then write number. And tell me which are the ones which are largest in size and largest in number. Come on, come on. All of you. Okay. Yes. Largest in size, largest in number. Yes, I want to see who is the first one to answer. Okay. Students, this one survival is around 10 to 20 hours. Okay, monocyte survival is around 10 to 20 hours. Very good. Neutrophils for number. Very good, very good. Okay, and size, monocytes. Very good, very good. Okay, good job, good job, good job. Okay, so largest in number is your neutrophils and largest in size is your monocytes. Such kind of questions can come, and if the teacher has not explained properly or if the student has not made a note of it properly, then you will get confused in this. Okay, now let's understand lymphocytes. Let's understand lymphocytes. Students, lymphocytes, we have already learned about lymphocytes, yes or no? We don't need to know much about lymphocytes. Here also, lymphocytes are circular. Okay, they are circular. The lobes are circular and they have large nucleus. Okay, they have large nucleus. And lymphocytes, when we talk about, whom do we talk about? B cells, B lymphocytes and T lymphocytes. Can you all see? Okay, B cells and T cells. Now, B cells and T cells, what do? B cells form antibodies. Okay, B cells form antibodies. And T cells will do what? CMI, that is cell-mediated immunity. Response, kills virus, infections, right? Yes, very good, very good. Most of you are answering. Good job. Okay, good job. Yes. Yes, very good. Cell-mediated immunity. Okay, fine. Clear? That's all. Okay, that's all. So, lymphocytes, we have B cells and T cells. B cells or B lymphocytes, T cells, T lymphocytes. B cells do what? Form antibodies. T cells does what? Kill viruses from the infection and also they do cell-mediated immunity. In B cells, we have plasma cells and memory cells. Okay, this in detail we have done in human health and diseases. Plasma cells are there. We have... we also have our memory cells, right? These two people also does the same job. Okay, clear? Yes or no? Can we do platelets? Okay, before platelets, students, here, let's write it here. Okay, let's write it here. Students, when the, I'll tell you. When WBC has to attack something, okay? When WBC has to attack something. Okay, so I'm drawing here red. I hope all of you can see. So look here. I've drawn a blood vessel. Okay, I've drawn a blood vessel. Now imagine infection happened. Okay, some kind of infection happened and it is inside somewhere. Okay, it is inside. It has to enter. Who has to enter? WBC has to enter. Now what WBC will do is with the smallest gap, this WBC will come out or squeeze out of the cell. Okay, it is in the blood vessel. WBC is going through the blood vessel, but they notice that tissue, outside one tissue is getting infected. What this WBC will do with the small pores in the blood vessel, it will squeeze out and it will go and attack that. It will go to phagocytosis. Okay, it will go to phagocytosis. Clear or not? Okay, yes, monocytes also are phagocytes in nature. Okay, phagocytes in nature. Students, this squeezing out and then going and doing this phagocytosis, no? Now imagine this is the allergen. Okay, phagocytosis. This condition or this is called as diapedisis. What is this called as? Diapedisis. Diapedisis. Okay, monocytes are also phagocytotic in nature. I'm not able to say the word again. Okay, so the squeezing out of WBC from the blood vessels to go and attack any kind of allergen that they have seen outside is called as diapedisis. Very, very important. Very, very important. When do they come out? They only come out when there is an injury. Okay, they come out only when there is an injury. Chuma, they will not come out. Okay, they will wait. Oh, injury has come. Let me go. Ready? Platelets. Okay. Yes. Thank you, Supra. Yes. Okay. Yeah. First of all, board is not used to attract anything. It is to write. Yes. Okay. Fine, students. Next one. Platelets. Platelets are also called as thrombocytes. Thrombocytes. Right? Students, I hope at least now you understood what these spammers are trying to do. Understood? When they cannot do some things, when they cannot beat other ways, they will do this. Yes, thrombocytes. Right? Thrombocytes. Now, students, thrombocytes also understand. Okay? One second. Yes. Okay. Thrombocytes are mainly for what? Clotting. Someone fell down. Okay. Someone fell down. Okay. Okay, this platelets are students, they are not true cells. Why? I'll tell you they're not true cells. Okay, first thing is they are not true cells. What do I mean by they're not true cells? Okay. See, look here. Okay, so students, okay, look here. This is a megakaryocyte. What is it? A megakaryocyte. Megakaryocyte. Okay, this megakaryocyte will be broken down. That means fragments will be formed out of this. Okay, fragments will be formed out of this like this, and these fragments form platelets. That is the reason why it is not called a true cell. Did you understand? Okay, that means it is a one megakaryocyte, one big cell is there. That cell is broken down or fragments are formed out of it. Okay, fragments are formed out of this. This is the reason why this is not a true cell. Why this is not a true cell. Clear? Clear? Okay, they are formed from megakaryocytes, which are special cells which are present in the bone marrow. Okay, special cells in the bone marrow. Now, let's write the normal count. How much is the normal count? We spoke about this when we were dealing with dengue, right? Dengue, right? Yes, students, we were dealing. Normal count has to be somewhere between 1.5 to 3.5 lakhs. How much? 1.5 to 3.5 lakhs. Yes, this is the normal count. If there is reduction, okay, if there is reduction, like not, if it's a major reduction, so what happens is when there is dengue, right, when there is dengue, what happens is the count goes to somewhere between 10,000. That means you can imagine from lakhs to 10,000 if it goes, then the body's clotting factor is gone. That means the person who was supposed to fight, person is not there, right? Person is not there. So it is a very dangerous case, okay? Now, students, platelets also, there is increase and decrease. That means deficiency. Okay, deficiency. And here, increase. Deficiency and increase. Clear? Yes. Okay, you can call it whatever, students. Ding. Oh. Where did we go? We shifted slides. Yes. So, what is deficiency called as? What did I tell you? Whenever there is deficiency, it is called as thrombo. Okay. Thrombocytopenia. Thrombocytopenia. Then if increase is there, thrombocytosis. Yes, thrombocytosis. That means deficiency of platelets, thrombocytopenia, increase in platelets, thrombocytosis. Right? Thrombocytosis. Clear or not? Clear? Yes. Look who is here! Oh, by the way, too many spammers today.
Oh my god, I can't see myself, is it? Oh,
Yeah.
we can.
There.
Which side is left and which side is right?
No, I don't know, sir.
Oh my god, this is crazy. Hey guys, what's up? Oh my god, Gopika ma'am is teaching you platelets and so much.
Yeah, so much.
Amazing body fluids. Oh,
Okay,
crazy.
wait, we focused. Yes, we are coming. See.
Wow, this is crazy. Yeah. And you know, the fun part, I'm telling you guys, yesterday I was watching Gopika ma'am and Baswa sir, and I was really feeling like left out and getting that FOMO, you know, the way they were having fun discussing the questions in NCERT line by line. How many of you have watched that session? Just let us know. You know, it was real fun, yeah, watching them. Trust me, if Balaji was taught that way, maybe I would not be an engineering student. I would be PCB student, maybe not a doctor, but at least PCMB student or something. Too good, too good.
Yeah.
Yes. So,
Sir is too tall, students, so little portion of the head will be.
oh, it felt like I was bald. Oh my god,
Students,
crazy.
I disappeared because I could feel like Shreyas sir is here. I don't know why. I just turned. I'm like,
Oh.
is this Shreyas sir? Yes, yes.
Hey,
sir.
fellows, like, yeah, over, no, your this thing, pre-boards and this and that. Some people are like, ma'am, sir, our should we watch recorded classes?
Oh.
Watch, man, watch. Again, if we take that live, same thing we'll do. No, instead, you think we are live only. We teach only like as if you are sitting in front of us. So watch those previous classes. Attend these current classes. Don't give stupid excuse. Sir, I don't like to watch recorded classes. One slap. Okay.
Okay.
So yeah, we are all in Bangalore. All three of us are in Bangalore, and Diksha ma'am is in this thing. So bye bye ma'am. Continue.
Bye.
Thank you
Yeah.
so much. Thank you so much. Bye bye guys.
Bye, sir.
Bye bye.
Okay. So, students, deficiency leads to thrombocytopenia, and increase leads to thrombocytosis. Okay. Increase. Yes, no doubt. Full conjuice. Okay, full conjuice for likes. Okay. Yes. So, students, let's continue. No getting distracted, even though we had so many things happening today. Okay, let's not get distracted. We are strong people. No one can stop our class. Okay, yes. Okay, told bye, everyone. Happy. Told bye to sir. Students, actually, I was drinking water and I went to reduce the AC, and I'm looking, Captain Shreyas is written. I'm like, who is this? Another captain. Okay, and then I see, okay, sir. And sir also was looking, when will I come out, or when will I look through the window, right? So like Champa and who was that? Pandu. We were waiting when sir can come in without disturbing the class. Okay, students. Okay, so students, platelets form the clotting factor. Okay, let's write here. Platelets. Okay, platelets. They form the clotting factor. Form clotting factor. Clear? Okay, they form the clotting factor. And what is their lifespan? Their lifespan is about, okay, 7 to 8 days. Got it, all of you? 7 to 8 days. Okay? Yes. Okay. Platelets, when the platelets number decrease. Now, what happens when the platelets number decrease? Now, you people only can think, no? These people are forming the clotting factor. So, if the platelets number are going to decrease, then if any injury happens, right? If any injury happens, right, then that injury will not heal. Clotting factor is not there, then the blood loss is going to be more, right? That injury will lead to blood loss. Got it? blood loss. Yes or no? Easy peasy. Yes, correct, Malar, correct. Same thing, penia is the word, na? Penia is the word. Leukopenia, erythropenia, thrombocytopenia. That's all. Okay, when cyto word is added, so we can pronounce it. Imagine saying erythropenia. Erythropenia also is fine, okay? Just penia word is important. Yes or no? Are we ready for the next topic? Next topic, done. Okay, students, now imagine I have taken the blood from one person. Okay, I have taken blood from one person. Okay, and I have centrifuged it. What have I done? I have it made centrifugation. Okay, centrifugation has been done. Now, when centrifugation happens, heavier particles settles at the bottom, lighter particles will come up. Simple, dimple. Okay, so here you see, when I centrifuge, my red blood cells are coming and settling in the bottom. Can you see the red color? Settling in the bottom. Then I have a middle layer which has the white blood cells and the platelets. Okay, and who is coming on the top? Plasma. Now I want all of you to remember, have you all seen this students, have you all seen this hair transplantation ads that keep coming? Have you seen that they take this some yellow color fluid from a centrifugation tube and they inject it to that person's head, same way they inject it to a person's face? That means it has become very common that we take the plasma of a person, we add some kind of, hormones which can actually improve the hair growth, which can actually give glowing skin, which can fade acne marks. Now, these has become the industry. That is why we have lot of type of facials, right? Before and all, what facials? Papaya facial, gold facial, silver facial, and all that you would have heard your parents talk about it, right? Now, have you noticed? In ads, if you see, just normally you just type hair transplantation videos, you will see they will take a yellow color fluid. In that yellow color fluid, they will inject some hormones which will actually help in the hair growth. That will be injected back to their scalp. Okay, so that is how, with the help of the centrifugation. See, understood? Doctor does not mean writing NEET, does not mean you have to do some boring job also. You don't have to do something that you don't like also. You can also become what? Dermatologist, you can become cosmetologist, right? All these things are there. Options are more. Yes, correct. Okay, plasma. Okay, yes. Students, now we are going to the next topic, which is called as blood grouping. Okay, now all of you tell me in the chat box which is your blood group. Which is your blood group? Come on, tell me all of you. So, blood grouping is also, we are going to study ABO blood grouping. ABO blood group, right? Yes. ABO blood grouping. All of you tell me in the chat box which is your blood group. Okay. Now, in ABO blood grouping, okay, very good. Okay, we have many negatives. Okay, no problem. If you can't type positive also, you can just type positive, ma'am. Okay. I don't know mine. Yeah, there will be some people like, it's okay. Some people don't know theirs. No problem. Okay. Yes, fine. Students, light is fine. Okay. Now, what is going to happen is ABO blood grouping means, how can we say it? It is presence and absence of antigens. Okay, presence and absence of antigen actually makes the difference. And what type of antigen is present? What type of antibody is present? Okay, now antigen, okay, antigen and antibody. Okay, antigen and antibody. This is two things we are going to. Students, I am A positive. A positive. Very simple. A positive. Okay. Yes. Students, understand, when we talk about antigen, it is present in the surface. What do I mean by surface? Now, I am A blood group. Okay. I am A. Right. My blood group is A. That means antigen is going to be present upper, surface. Surface. This is the antigen. Clear? Antibody is going to be present where? Inside the cell, okay, or it is present in the plasma of the cell. It is present in the plasma of the cell. Clear or not? So antigen is present on the surface, like that satellite, no? It sits on the surface. And antibody is present inside. Antibody is present inside. This is not the antibody that you kill each other. No. Okay? Yes, yes. Oh, wow. Wow, wow. There are... Durga, you will definitely be in your dream college and you can definitely check your blood group. Okay, do not worry. Students, this antigen, when we talk about, is not the bad antigen. That means like the foreign particle. It is actually something that can induce a response. Okay, that can induce a response. Okay, induce response. Yes, done. Okay, now let's understand the blood grouping. Okay, let's directly write. There's nothing for you to like learn. It's only learning part. There's very less part for you to by heart. Okay, students, so let's write blood group. Okay, blood group. Then we will write antigen and antibody. Now, see, now blood group, antigen, antibody. One thing we all know, antigen and antibody should not be the same. That means what? I cannot keep, now say example, let's write A. A. Okay, students, your positive, negative, we will be studying in your recess blood grouping. Now you only understand ABO blood grouping. Okay, now blood group is A. Okay, blood group is A. Clear? Antigen will be what? A only. Can I keep B? Can I keep B? If we have to induce a response. Can I keep B as the antigen? No, I cannot keep B as the antigen. I have to keep the antibody. That means antigen and antibody should be opposite, ulta. Antigen, my blood group and my antigen has to be the same. So what is on the surface has to be the same. Now B, all of you tell me. B. Definitely antibody has to be opposite. A. Simple. So far simple. Okay. Then, students, AB. Anybody AB in the class? AB in the class? This AB person will have both A and B antigen. That is why they are AB. No, that is why they are AB. Right? Then, antibody. If I see, they have both A and B. I cannot put B and A as antibody. Still, they will have problem. So, I will put no antibody or none. None antibody. Okay? None antibody. Now, you can't. Okay? Now, students, do we have spammers? No, right? Yes. Okay. Then, students, O. O. Okay? O, the problem with O is I cannot give both the antigens too. Because O is like neutral. O is like neutral. No antigens on that. Okay, so none. But antibody they should have. Okay, antibody they can have. A comma B. Because they don't have any antigen. If I put A, if I put B, what reaction could happen? Agreed all of you? Agreed all of you? Got it? O does not have any antigen. But they have antibody. Because antigen is not there, I'll put antibody. Yes or no? Simple. Simple, easy. Okay, fine. Now, look here, students. All of you look here. Can you see the image? Should I move more to the side? Now, look here. Group A. Okay, we have group A. Okay, yes. Should I move to the side or we can still see? Okay. Yeah. Okay, students, look here. Group A. Can you see group A? This group A has this is the blood group. Okay, A, B, C, D. Okay, first we will try to understand this. Antibodies in the plasma. What is the antibodies in the plasma? Anti-B. Okay, so blood group A will have anti-B. Okay, then wait, I'll use black. Yeah, they will have anti-B. Now, blood group B will have anti-A. Simple. Now, blood group AB, I cannot give A or B. Problem will happen. So, let it be none. Okay. Then, group, that is O, blood group O. Because they don't have any antigen, whatever antibody I give, does not matter. Right? Does not matter. Okay. Yeah, actually, I've heard some people telling 0 instead of O also. Right? 0 instead of O. Okay. Now, students, antigens in the RBC. Okay, antigens in the RBC. Can you see A is the antigen? That is why, see, they are all on the surface. They are like satellites. They are everywhere. Okay, surface. This is present on the surface. This is B antigen. Can you see? B antigen, green color they have denoted. AB antigen. AB antigen. That means both are present, right? So whenever, this is simple way to remember. Whenever both the antigens are there, we will not give them any antibody. When no antigens are there, we'll give both the antibody. Problem should not be there, right? Problem should not be there. And then group O, same thing. None, no antigen given. Clear? Yes. Good job. Good job. Okay? Yes. Now let's understand one thing. Okay, let's understand one thing. We will draw it here only. We will draw it here only. Who is who? Not, not who is who. Who is universal donor, universal recipient? This also you have studied in your small classes, but still we will do it. So students, O is there, A is there, AB is there, B is there. Okay, got it all of you? O is a universal donor. Okay, O can give to A, O can give to B, O can give to AB. Clear to all of you? O becomes a universal donor, especially O negative. Okay, universal donor. That when we study rhesus blood grouping, I will tell you about that. So universal donor. Now, AB, it can take blood from, okay, let's draw it in another color. Okay, it can take blood from A also. It can take blood from B also. It can take blood from O also. So this becomes a universal recipient. That means it can take blood from anyone. Universal recipient. Simple. Okay. Universal recipient. That means it can take blood from O, A, B. No problem. No tension. Okay. Same way we have universal donor. O person can give blood to anyone. Clear? Okay, fine. Now, RH grouping or rhesus grouping. Student, this actually first came from a monkey. Monkey, our ancestors. Okay. Monkey, they found this rhesus blood grouping. So, it was found from a rhesus monkey. So, they called it as rhesus blood grouping. Nothing, there's no, what did I significance like why this is there or what happened and all, but then it just understood that it came from rhesus monkey, so it was called rhesus factor. What is it called as? Rhesus factor. All of you got it? Okay. Yes, rhesus factor. It was from a rhesus monkey. Rhesus monkey. Yes, very good. Okay. Now, what does it mean? What does this rhesus factor or whatever mean? Okay. Basically means, students, positive and negative. RH positive, RH negative. That means this positive and negative had to do something with this blood grouping. Okay. Had to do something with the blood grouping. So, imagine there is our blood group. Okay. A is there. It will have, I have RH positive. That means I have the rhesus factor. But then say someone who is there, who else is there? Students, who is negative? Okay, imagine one person is negative. A negative is there. That means that person will not have rhesus negative. Okay, that person will not have negative. Clear? Clear? Okay. Fine. So, with rhesus factor positive, without rhesus factor negative. Okay? Yes. Got it, all of you? Yes, what's happening? Okay, fine. Got it. Fine. Okay. Now, if this is clear, now all of you tell me in the chat box, do you have rhesus factor or you do not have rhesus factor? And also tell me in the chat box, what is the antigen that you have and what is the antibody that you have? Come on, all of you. All of you. So I am writing mine. Okay, let's write mine. Okay. Right? A is mine. Right? I have antigen A. I have antigen A. I have antibody B or anti B. Okay. Okay, I have antibody B and I have rhesus factor. I have rhesus factor. All of you write yours. All of you write yours, which antigen you have, which antibody you have, and which kind of rhesus factor do you have. Quickly, quickly. Write it, write it. Then we will go to the next topic. Students, whoever does not know your blood group, take my blood group, A positive. Take my blood group, A positive. Okay. Great, great. Okay, I have rhesus factor, no antigen, and antibody AB. Come on, who can guess that? They have rhesus factor, no antigen, but they have antibody A and B. What is the answer? AB. AB. Yes or no? I'm not donating blood, so it's fine. I'm just donating the name. Okay. So students, now I think it is easy for you. All of you understood, right? All of you understood? Yes. Students, so RH incompatibility. That means what happens? Now, even though we told that RH significance is not known, okay? RH, when I reduce, I get cold. When I increase, I get it's too chilly, right? Okay. Students, RH incompatibility means mismatch. Mismatch of our RH factor. Mismatch of our RH factor. Clear? Okay. RH factor. Okay. Yes, very good. Now, students, what is happening? Imagine it only happens when the mother and daughter case. Okay, let's see. I have 1 second. I think I have added images. Yes, okay, I've added here erythroblastosis fetalis. Okay, let's do it here only. Then we will come back to that. Okay, students, mismatch happens. That means what? Simple. Now, let's take this one. Okay, let's take this scenario once the ad goes. Yes, let's take this scenario. Okay, now imagine father and mother. Okay, there is father and mother. Father and mother. Okay, father and mother is there. Father has RH positive. Mother has RH negative. They both got married. Okay, father RH positive, mother RH negative. They both got married. Okay, and the mother is going to have the first baby. First baby or the first pregnancy is going to happen. Okay, so during the first pregnancy, if you all notice that image, you can see the mother has negative, RH negative. That means RH factor is not there or the negative factor is there. But the baby is RH positive. Okay, so we have RH negative and we have RH positive. Now, all of you tell me, during pregnancy, does blood mixing up happens between the mother and the fetus? Yes or no? Yes or no? Tell me, students, do mixing up happens? Okay, I have added all these beautiful images just so that you people get a better understanding of the chapter. I have added so many images in the further also. So I hope, even though the class might not be like the board pattern, I hope you people still understand the concept. Understanding concept is important. Okay, we can do the same chapter again in board also, no problem. Later we will do. Okay, before our NEET exam we will do. Okay, students, does mixing up happen? No ma'am, yes ma'am. Okay, no ma'am. Okay, students, usually or 100% mixing up of blood does not happen when the mother is carrying the fetus. But when the placenta ruptures, okay, when the placenta ruptures, that time mixing up of blood happens. Mixing of blood happens. That too not a lot, in a very less amount. Okay, in a very less amount. Now imagine the mother is conceiving a baby which is RH positive. Like the image. Can you see the baby is Rh positive, mother is Rh negative. Mixing of blood has happened when the placenta ruptured. That means when the baby is going to come out, right? If the parturition has happened. So when the baby is going to come out, there is a slight mix of blood. Slight mixing of blood. Now what is going to happen is, look here all of you, look at this image. Okay, look at this image, student. This is the first, okay, first scenario. When the baby, that means when the placenta was about to rupture. Okay, placenta was about to rupture. This, during that time, this RH, some of the RH positive has entered the mother. That means from the baby, the RH positive entered the mother. Now you tell me, simple, right? Simple. Is there a lag, students? Is there a lag? Yes or no? What is happening? Why are you people spamming? Okay. Okay, fine. Okay, look here, all of you. Students, look at the first scenario. So, the placenta was rupturing. Some amount of blood, okay? Some amount of blood got inside the mother. Now, what is the mother's body going to think? Mother's body does not have the affection that, oh, it is my baby, oh, it is a fetus, okay? That the body does not know, right? Our cell mediated response does not know. The moment Rh negative got into the mother's body, okay, Rh negative got into the mother's body, the minute that time, this is considered as a foreign particle. Now what is happening? Definitely if this is considered as a foreign particle, the mother's body has started forming the antibodies for it. The mother's body has started forming the antibodies for it. Now first baby, nothing has happened because the pregnancy, delivery happened, no problem has happened. Okay, no problem has happened, delivery happened properly, so no tension, no tension. Now look here all of you, the mother is going to conceive the second baby. The mother is going to conceive the second baby. At the first scenario, RH got into the mother's body and that is considered as a foreign particle. Against this foreign particle, the mother's body is making antibodies. Now imagine during the second baby also, the mother is having an RH positive baby. Okay, the second baby is RH positive. Now what is going to happen? Whatever antibodies are already formed, they will have a memory of this, right? When the second placenta rupturation, or before, when the second baby is inside the mother's womb, you know that placenta can transfer, right? When the placenta can transfer water, gases, all that, it can also transfer antibodies. All of you remember? Yes or no? Yes or no? The mother, that means from the placenta, the baby can get antibodies from the mother. Now, what is going to happen? They have already formed antibodies against Rh positive. Now, these antibodies will start entering and trying to kill the Rh positive in the baby. Okay? Okay? Got it, all of you? Yes or no? Yes or no? Got it? So now what is going to happen? The second baby's life is at risk. Okay, it will try to kill all the Rh positive by entering the baby, and it is going to risk the baby's life. It is going to risk the baby's life. Okay, that is what is happening here. Can you see here? Antibodies are already active. Second baby is happening. Can you see the antibodies have entered inside? If you look here, see. Okay, antibodies have entered inside the baby. Now what is it going to do? It is going to kill the baby, or it is going to continuously kill or remove the blood, right? So that will lead to the hemolysis. That means it will lead to okay, it will lead to agglutination, right? It will lead to agglutination. Now students, what is the solution? Everything should have a solution, right? Students, the solution is basically giving a rogum vaccine, Okay, look at this. This is the solution. Can you see here? This Rogam vaccine will correctly go and remove the formed antibodies against the Rh positive. Then the body is fine, right? No more antibodies will enter the baby. Understood, all of you? This Rogam vaccine, okay, this Rogam vaccine will fight against erythroblastosis fetalis. Clear? Simple? Okay, the solution is to give Rogam vaccine, which will go and remove or act against the antibodies formed. Okay, remove the antibodies formed. Okay, against Rh positive. Definitely lot of couples are there who have positive and negative. Doesn't mean that no one marries positive and negative people. Nothing like that, right? So there should be a solution. The solution to erythroblastosis fetalis is Rogam vaccine, which will remove or attack or act upon the antibodies formed against the Rh positive. Clear? Okay, clear or not? Easy? Easy? Okay, so students, to avoid this scenario, this vaccine is already formed, because otherwise how many people would die, right? How many second babies would die, right? Because look here, this is very common, no? The antibodies will start entering inside and start killing, or it will lead to agglutination. Lead to agglutination. Lead to agglutination. Then RBCs will rupture. Right? That will lead to hemolysis of the newborn. Yes, hemolysis. Yes, Kavya, even in Malayalam, Rogam means disease. Rogam means a disease. Okay, Rogam means a disease actually. So, yes. I think it's same in Tamil and Tamil and this one. Telugu also. Telugu also it's the same. Huh? Yes. Correct. Got it, all of you? Yes? Easy? Okay. Now we will understand coagulation of blood. Okay? Okay, I wrote here same thing. Okay, mismatch. Yes or no? Clear? Very good. Okay. Telugu also? Fine. Great. Okay, now students, coagulation of blood. That means now we understood platelets, that it is going to do clotting factor. Now, understand there are around 13 clotting factors. How many are there? 13. 13 clotting factors. Or 13 factors itself you can write. Now you don't have to study. Previously you had to study. Now you don't have to study. Okay, clear or not? Okay, 13 factors are there, students, and it is written in Roman numbers. How is it written? Roman numbers. Roman numbers. Okay, 1, 2, 3, 4, like that. Okay, out of which your third and 13th one are secreted by your platelets. Secreted by your platelets. Yes, got it? Got it? Yes, Laharika, tell me your doubt. Tell me your doubt. Students, first one and the 13th one is secreted by the platelets. That is why if there is a decrease in platelets count, then you have chances of high blood loss. Okay, lot of blood loss will happen. Clear or not? Okay, and where will be the rest of it formed? That means 1, 2, 3, 4. All that, okay, 1, 2, 4, all the rest of that will be formed in the liver. Secreted by the liver. Okay, rest is secreted by the liver. Clear or not? Okay. Yes. Okay, fine. So students, how does this clotting happens? How does the clotting happens? Yes, we will come to that, Sharath. Now we will come. Okay, students, look here. An injury happened. An injury happened. You went and fell somewhere. Okay, you went and fell somewhere. Okay, that is the injury that has happened. Now, as soon as an injury happened, first thing that will be released is your thromboplastin. Okay, thromboplastin will be released, and this thromboplastin will next activate your thrombokinase. Yes, thrombokinase. Now this thrombokinase will activate something called as the prothrombin. Yes. Okay. Yes. Yes. Okay. Prothrombin. Okay. Now this prothrombin will activate thrombin. Will activate thrombin. Okay. Yes. Students, maybe Dr. Strange internet might be an issue, so do not attack him. I think his internet has a problem, so still he is lagging. Okay. Yes. Fine. Prothrombin. Yes. Clear? Yes. So many spammers, yeah. Okay, whatever. Thrombin and so prothrombin will activate thrombin. Okay, how is the activation happening? With the help of calcium. With the help of calcium. Okay, clear or not? Clear or not? Now, students, this thrombin will again, with the help of calcium, will help in activating fibrinogen. Fibrinogen. This fibrinogen will again, okay, fibrinogen is actually soluble. This fibrinogen will activate fibrin. All of you know this, fibrin. Okay, and which is insoluble. Insoluble. Okay, now students, what is this fibrin going to do? It is going to form a mesh. Have you all seen a mesh? Okay, now imagine this is the wound where you have. They will form a mesh. Now, when they form a mesh, now imagine this is a mesh. If RBCs are coming, it will get stuck. Okay, if RBCs are coming, it will get stuck. Okay, yes. Got it, all of you? Okay, yes or no? Yes, clear. Okay, now students, fibrinogen was a soluble one. Fibrin is an insoluble one. Okay, fibrinogen is a soluble one. Okay, fibrin is an insoluble one. Students, this chart is not moving. 1 second, let me just refresh. Let me refresh. Students, please avoid spamming, students. It's actually not helping me. It is actually disturbing me. So please stop spamming. If you have any doubts, please keep it to the last. Do not disturb the class. Okay, whoever is disturbing the class, I'm going to remove, even if you are a very good student of mine or a whatsoever. Students, at this point now I'm getting irritated. Okay, you should stop texting, and you should stop texting unnecessary. Listen to the class, make notes. Rest we will see later. Okay, I will ask you if you have any doubts. That time you please tell. Okay, you should also understand that I'm standing and teaching here, and it is very disturbing to see some kind of messages, right? You should also think that I'm a human. I have feelings. I get hurt, right? Yes or no? So let's avoid unnecessary things. Yes, okay. Students, so this mesh formation will lead to clot and coagulation. Clot and coagulation. Clear or not? Clot and coagulation. So students, what is happening? Injury happened. Thromboblastin will be released. The moment an injury happens, thromboblastin will release. Thromboblastin will go and activate thrombokinase. Thrombokinase will go to prothrombin. Prothrombin will go to thrombin. Thrombin will go to fibrinogen. Fibrinogen will go to fibrin. Finally, fibrin will form an insoluble mesh which will actually trap this RBC from losing. That means blood from losing. RBC will be there, WBC will be there, right? They will stop the loss, right? Blood will go like this, it will stop. Okay, clear or not? Easy? Easy? Okay, now we all know about blood banks, right? We all know about blood banks, right? So in blood banks, what happens is they have to store the blood for a very, very longer time, right? They have to store the blood for a very, very longer time. That time, what do? They add something called as sodium oxalate. They add what called as sodium oxalate so that this clotting can be avoided. It will remove actually the calcium. Students, here also we need calcium. Okay, here also we need calcium. Okay, here every step we need calcium. Okay, calcium is something which will come from external, right? From milk and other things, calcium will come externally. It is not formed in the body. It has to come externally. That's why when you have calcium deficiency, your healing also becomes slow. Okay, so in blood banks, they use sodium oxalate, and that oxalate will remove calcium. Okay, it will remove calcium, and this removal of calcium will avoid, right, that coagulation will not happen. Clotting of blood will not happen. Clear? Easy? Very good. Okay, sodium oxalate. Okay, students, yes, this much is clear. Now look here. Have you all seen this? I think during the COVID time, it was very famous. People were all keeping those Uno cards, that other Benton cards, Pokemon cards, and they were doing this. All of you remember? They used to make peacock, they used to make Indian flag and all that. Have you noticed all of this? Now, coagulation is a cascade reaction. Cascade reaction. That means what? One will activate another one will go on. If one step also is missed, this clotting will not happen. Okay, so thrombokinase, next step, it is like a waterfall. It is like a waterfall, one after the other. So that kind of a reaction is called as your cascade reaction. So coagulation of blood, or this entire process of thrombokinase till your fibrin, is a cascade reaction. Clear or not on this? Clear? So students, look here, I have added the factors which you don't have to study actually, but you should know. See, third factor, that is your thromboblastin. Okay, thromboblastin is secreted by your platelets, and your last 13th factor, that is your fibrin stabilizing factor, is secreted by the platelets. Rest all of them are secreted by the liver. Okay, rest everything is secreted by the liver. Clear? Clear? This one and this one. Students, look here. Can you see how the mesh formation is happening? Can you see how it is forming? It is like, if you leave your room unclean for, if you leave your room without cleaning, even after your mom scolds, if you're not cleaning that room for a very long time, you can see web like this everywhere. Have you seen ever in your home? Between your books and all, if you're not planning to open your book for a very long time, you will start seeing such web formation. So if you see here, you can see RBCs are caught here, WBCs are caught here. Can you see? We all hear, from our parents, remember before, when we were in school, we used to get 2 months of vacation, That time our parents used to tell, open your bag or book at least once, otherwise maybe rat would have eaten it, or maybe a spider would have built its web inside, right? This looks like that, Remember, all of our parents would have told us at least once, right? And before, one day before the vacation, we will dust all our books and we'll be like, oh, no, cockroach is not there, nothing is there. My throat is telling. Okay, students, now we will have a break. Okay, now we'll have a break. My throat is paining. So we will take a small break and then we will come back. Okay. Okay, no, after this we'll take a break. Come on, solve the questions. Solve the questions. Come on. A person with AB blood group, okay, has what and all? a person with AB blood group will have what and all? Do they have both A and B antigens in this plasma? Lacks, this is also a PYQ question, that means NEET question, okay? NEET question. 2017 question, I guess. Lacks any antibodies on the RBC surface, can receive blood transfusion from a person on its own, can donate blood to all the other group recipient. What is the answer, students? Come on, tell me what's the answer. Yes, yes. Students, yes, I will catch you on some question here. Let me see what's the answer. Okay, okay. Only YS and pharynx have told 3. Only YS and pharynx have told 3. No, YS changed her mind. Okay, let's catch and let me catch you all. Students, I told you this is a NEET question. This is not a 10th standard students question. See, has A and B antigens in the plasma? Where is antigens present? On the surface. And how can we have it in the plasma? First question they caught you. 4 marks you people lost, okay? 4 marks you lost because you didn't read the question. Lacks any antibodies on the RBC surface. Lacks any antibodies on the surface. Correct? Yes? Okay. Now you people tell me the answer. All of you lost 4 marks. 4 marks because you didn't see this. Okay, antibody is in the plasma. Antibody is in the plasma. And antigen is in the surface. Now they are telling lacks any antibody on the RBC. Yes, all of you got negative marks? No. Now you should tell me, did you get, I think no one got, I think one person, pharynx or someone got 8 plus 4 marks. Okay, 12 marks. Others all are in 8 only. Yeah, I could see that. Why, yes. Immediately she deleted. She's like, oh, you only I'm the person who's telling 3, others are all telling 1 and 2. Let me go behind the crowd. No, should not go behind the crowd. So, can receive blood transfusion from a person of his own blood group. Can donate, they cannot donate blood to all the blood groups. They cannot donate to all the blood groups. Okay. So, answer is 3. Answer is 3. Yes or no? Okay. So, those who got 12 marks, I'm proud of you. See, this is how we catch you people, right, in the questions. This is why NEET is difficult. Students, look here. AB blood group have no antibodies in the plasma. Here they have given what? No antibodies in the surface. This also people can get confused. 8 minus 4, 4 it seems. Okay, next question. The universal donor and acceptor will be. Who is the universal donor and the universal acceptor? Come on. Let me know the answer. This I don't think anyone will go wrong. I mean, I have hopes. I have high hopes on always on my students. Yes, tell me. Quickly, quickly. Yes, what's the answer? What's the answer? 2. Okay. O negative and AB positive. Very good. Very good. 2 is the answer. Right? Yes. Now you will get 12 marks. Okay. Now you would have got 12 marks. Okay. Next question. Oh, I didn't say this. No, sorry, students. First, I'll tell this, then you answer. Okay. Here, students. Here, right? Here, this portion. We also need vitamin K. Okay, vitamin. Okay, vitamin K for the formation of fibrinogen. Okay, fibrinogen or your fibrin. Prothrombin, actually, you can also write prothrombin also. Okay, yes, vitamin K is very, very required for the formation of your prothrombin, or in some places you can also see fibrin, fibrinogen, fibrin. Okay, got it, all of you? Okay, now I'll put the question. Got it? Yes. Okay. Shall I give the prothrombin is the answer? Okay, prothrombin is required. Vitamin K is required for the formation of prothrombin. Now, easily you will get 4 marks because I told the answer. Okay, vitamin K is required for the change of prothrombin to thrombin, synthesis of prothrombin, change of fibrinogen to fibrin, formation of thromboplastin. Thromboplastin. Which is the answer? Which is the answer? Change of prothrombin to thrombin, synthesis of prothrombin. Which is the answer? Why are you people telling 1? 11. Oh, 11 marks. Oh, okay, okay. Sorry, sorry. 11 marks. Okay, good, good people. Very loyal students. Yes, very good. 2 is the answer. Synthesis of prothrombin. We need vitamin K. Okay, 4 marks. 4 marks. Now tell me the total. Now tell me the total. Students, next we have heart. Okay, next heart. Students, we will take a 10 minutes break. Okay, 7:18 we'll come back, or else 7:20. Right? Got it? I'll take a break. Too much break I need. I need real break. Right? Yes? Good job, good job. 15, 16. Okay, by then come back at 7:18. Okay, don't run away. Those who are in the class, don't run away. We have to learn heart. Very, very important. Very, very important. Those who are not there for heart, I don't know. You think questions will come only from blood? Okay, people who are not going to join back, do you really think question only comes from blood? How can you not be there for the heart? Okay, see you all. See you all, students, at 7:18. Friends, are you all back? Yes. Let's see if all of you are back. I'm back. Okay, let me just drop it. Join back. Yes. Okay. Yes. Yes, yes. Most of you are back. Good job. Students, all of you, please bring at least 2 different color pens so you can draw the heart, right? Right? Yes, all of you are back. Okay. Students, lymph, I have just added a snip of NCERT. So let's see what the NCERT says. As the blood passes through the capillaries in tissue, some water along with some small water-soluble substance move out into the spaces between the cells of the tissue, leaving a larger protein and most of the formed elements in the blood vessels. Now, we know plasma has some kind of proteins. Our blood has some kind of formed elements, some minerals are there, some water soluble contents are there. Now what happens when these are lost, like when they are going from here to there, they're losing, right? Now you see, after break, only the needed NEET aspirants have come. That means who are really wanting to crack NEET, only they have joined. That means what? I have not lost any good content, right? I have not lost the good students from my class. I have lost only the students who are not very serious, right? Not very serious. Now, students, understand here what is happening is this fluid released out is called as interstitial fluid or the tissue fluid. That means whatever is getting lost, between when it's going from one place to another, that is called as interstitial fluid or tissue fluid. Okay. It has the same mineral distribution as that in the plasma. What did I say? What did I say? I told the same thing. Yes. Oh, so many of your net pack gets over at this time, no? That is the problem actually. Some of you leave. Okay, okay. No problem, YS. Okay, so it has the same mineral distribution as that in the plasma. Exchange of nutrient and gases, etc. between the blood and the cells always occur through this fluid. Okay, an elaborate network of vessels called as lymphatic system collects this fluid and drains it back into the major veins. That means whatever is getting lost between the tissues, whatever good content is getting lost between the tissues will be collected by whom? Will be collected by the lymphatic system. That will be poured back into the major veins so that we do not lose anything. Imagine every 5 minutes you're losing all, one is losing fibrinogen, one is losing albumin, one is losing globulin. Where would our situation be, right? So this lymphatic system will do that. Okay, they will pour it back into the major veins. Okay, now the fluid present in the lymphatic system is called as the lymph. Simple. Whatever came from the tissue, I'll show you a very beautiful image. Okay, whatever came from the lymphatic or between the tissue fluids, that will be collected by the lymphatic vessels. That is called as lymph. Whatever is there inside the lymphatic vessels is called as lymph. Okay, and they are colorless fluids. We know this. We have been studying from 8th standard. Containing specialized lymphocytes. That means they're against any kind of antigens or any kind of pathogens that is coming. Okay, pathogens that is coming, which are responsible for the immune response of the body. Lymph is also known as an important carrier of nutrients. Easy, simple. Okay, and nutrients, hormones, etc. Fats are absorbed through the lymph in the latticelles present in the interstitial villi. That means villi is what, students? Finger-like projections, right? In that, fats will be accumulated. Now, all of you look at this image. Can you all see? Yes or no? Can you all see the image? Why the chart's not moving? What is happening? Students, come on, let me know if you can see it properly. Yes? Okay, great. Yes. Or is the live still not reached there? Yes, very good. Okay, so students, look here. This is your tissues. Okay, now what is happening? Okay, this is, imagine your from any of the veins or something, loss is going to happen. Okay, so what is getting lost here? If you see, this is water. This is water. Okay, water is there. Dissolved substances are there. WBCs are there. If we lose WBCs, then who is going to do phagocytosis? Who is going to fight? Right? No one is going to fight. No. So look here. Between this, what is happening? There are some losses are happening. Some water is getting lost. Some dissolved substances getting lost, and they're all just going somewhere. No place to go. Right? It is just losing. We are losing it. Now, what is going to happen? We have a person who is going to come and help. Okay, we have a person who is going to come and help. Who is that? Our lymphatic vessels. Who is coming to help? Lymphatic vessels. These lymphatic vessels will collect whatever is being given out from the capillaries, and that whatever is coming out of the capillaries is called as interstitial fluid. That interstitial fluid will be collected by our lymphatic vessels, and whatever is inside the lymphatic vessels is called as lymph. Easy, easy. Such a good diagram, no? Such a good diagram, right? It's like just collecting, just like collecting. Okay, something we have kept on the down, whatever is leaking from the top will be collected there. That becomes one fluid tissue. That becomes one fluid tissue. Any doubts so far, students? Any doubts so far? Yes or no? Is there any doubt? Anyone has doubt? Okay, yes, easy. Just look at the diagram, you will understand. Okay, so this lymphatic vessel, whatever is there is called as lymph. This lymph has rich in nutrients, right? It is rich in nutrients because whatever is coming out of the capillaries are important. So whatever it is collecting also is important. That is called as nutrients. Okay. Okay, simple, easy. Yes, fine. Now we are going to study heart. Heart. Are you all excited for heart? Students, look at the heart beating. Can you see the heart beating? Yes. I told you I've added a lot of images. Can you see the heart beating? Is your heart beating? Yeah, it is like a game. Very good, Malar. It is like a game, no? Like, okay, like, have you seen that apple, orange, all that fall? You have to do that clash, Clash of Clans. No, something you have to clash and do, students. Okay, I forgot what is that. But you have to, like, strike the apple, orange. The same way, these lymph vessels will be there, which will take up everything from the capillaries, right? Okay. Heart is complicated. We will break it down. Okay, we will make heart jujube. We will make it easy. Okay, we will make it easy. You will study some vocabularies from me, which is not even a word. Okay. Yes. Okay, students. Okay, let's see. First, we will see where this heart is located. Okay, it is located. This word we have already learned lot of times. Located in the mediastinum. That means what? Between the both lungs, heart is present. Okay, it is present in the mediastinum. Okay, where does it actually be there? It is exactly present in the cardiac notch. It will fit into the cardiac notch, because of which why it is moved a little towards the left. See, can you see? It is towards the left. Have you seen heart straight? That is your heart, whichever you send, no, that emoji, that is only straight. But the real heart, even if you see on YouTube also, the heart which people are using, see, that is also to the left. So smart, see, so smart. Students, it is, that cardiac notch is to the left lungs. It fits the cardiac notch to the left lungs. Okay, that is why it is a little tilted towards the left. Okay, now what is the size of the heart? Size of the heart, this much. If you fold your fist, this is the size of your heart. Can you believe this much size of heart? Only you people think about 100 things. Okay, this much size only you people think about so many things. You have the, some people have the patience, and like with this small heart, they do so much hate, revenge, spammers and all that, right? Right? Okay, size of the heart is the fist size. Okay, size of your folded hands. Yes, ready? Okay, and students, what is the shape? If we look at the shape, it is slightly triangular, right? It is slightly triangular. Slightly triangular because of the shape. How is it going? Okay, yes. Then in males, okay, males have, students, males heart weigh a lot. That is why these people know they have too much space. It is around 280 to 240 grams. Male heart is around weighing around 280 to 240 grams. Females are very lightweighted, but people will not agree because we complicate things later. No, they tell girls overthink, girls fight, right? Okay. Yes. Students, so male heart weighs around 280 to 340 grams. Okay, and female heart weighs around 230 to 280 grams. Okay, so who is lightweighted? People, come on, text in the group. Who is lightweighted? Who has light heart? Lightweighted heart, who is having? Will not agree now. Are you people going to fight? No, right? Yes. Okay. Clear? Okay, fine. Now, next we will understand the wall of the heart. Wall of the heart. Okay. Before we understand the wall of the heart, we will also understand your open and closed circulatory system. Then we will come back to the wall of the heart. Okay. Who has light-weighted heart? Very good. Girls have light-weighted heart. Females have light-weighted heart. Right? We are light. That I don't know, students. That I'm not commenting on that. But yeah. Okay, students, listen here. So there is two types of circulatory system. One is called the closed circulatory system. One is called the open circulatory system. Okay, we know about this. We have always learned about it, right? Okay. Okay, see, I told you one or the other person will tell, ma'am, but they complicate things more. Girls complicate things more. How can they have light heart and they complicate things, right? Okay, students, yes. Now look here, your closed circulatory system and open circulatory system. Now open circulatory system, what and all they have? So this is the heart. Okay, this is the heart. Okay, this is the blood vessels. Okay, blood vessels. Here, if you see what is happening, they have openings. Okay, they have openings called as sinus. They have openings called as sinus through which the blood freely moves in and out. Okay, so open circulatory system means they still have heart, they have blood vessels. Now their capillaries are not joined together. They have space in between called as the sinus. So through this sinus, the blood flows freely. The blood flows freely. Got it, all of you? Okay, yes? Yes or no? People are, yes, very good. Sinuses through which the blood flows freely. Blood flows freely. Okay, very good, very good. Good job, good job. Yes. Okay, so what is happening? Capillaries are not present in this people. Okay, everything else is there. There is no capillaries. They have sinus. Okay, they have sinus. So they do not have, they have no capillaries. Okay, they have no capillaries, and instead they have sinus, which are small openings through which the blood actually moves. Small opening through which the blood actually moves. Okay. Okay, fine. We will find such good examples, no? Now, students, let's write the examples. Okay, let's write the examples. Who has this kind of a heart? Okay, arthropods, cockroach. Remember cockroach? Oh, color didn't change only. Yes, green stump. Okay, students, who has this kind of a heart? Arthropoda. Arthropoda have this kind of a heart. Okay. Mollusca also has, except your cephalopoda. Okay. Okay. Except some exception is there. Your cephalopod mollusk do not have open circulatory system, but they have closed circulatory system. Clear or not? Okay. And same way, annelids also have your okay, annelids also have your closed circulatory system, but leeches are an exception. Okay, leeches are an exception. Got it, all of you? Example. Okay, example, arthropod, mollusk and leeches. Here exception is cephalopod mollusk. Okay, clear? Clear or not? Clear or not? Okay. Yes. Cockroach is our first session of Super 6 series, right? Yes. Students, now let's see closed circulatory system. Look here. Here also we have heart. Here we have blood vessels. Here we have capillaries. So here what is happening? That sinus is not there. That opening is not there. Instead we have capillaries. Now if blood has to go, it cannot just jump like that, right? If the gate is closed, can you chumma jump? No, but if the gate is open, you can definitely jump, right? So here capillaries are there, so the blood cannot just move freely. They have to move through a path. That is why this is called as closed circulatory system. Okay, a path is followed for the flow of blood. Flow of blood. Very good, clear? Okay, understood? Easy peasy. Yes. Now, what is the examples? Let's write the examples. I told you first one was cephalopod mollusk. Okay, cephalopod mollusca. Yes or no? Okay. Then we have who? We have Annelida. Exception is leech, which we have already written there. Then we have vertebrata. Vertebrata. Got it? Clear? Okay, easy? Okay. Now, students, in vertebrata, there's a paragraph which is given in your NCERT. That is what we are going to focus on. Okay, that is what we are going to focus on. That means in vertebrata, they are talking about fish. Okay, they're talking about amphibians. Are you all there? Subhashni, YS, YS when, sorry, Sanvi, Rupa, Sharat, all of you are there. Yes or no? Reptile, aves, and us humans, right? So mammals. Yes, all of you are there. Give me attendance. I'm calling you attendance. Okay. Students, look here. In fish, okay, in fish and if you say both your fish, what is happening? This is how the structure is. Okay. That means they have two valves. Okay, two. That means they have auricle, ventricle. That's all. Two chambers they have. They have two chambers. Okay. Two chambers. Okay, fine. Then amphibians and reptiles. Okay, amphibians and reptiles have three chambers. Three chambers. How is the three chambers? Again, we drew this in frog. Okay, we have right auricle, left auricle, and you have ventricles. Okay, both the auricles are there, but only one ventricle is there. Okay, this is the same for both of this, but reptiles have an exception. Who is that? Crocodile. Crocodile has four chambered. Crocodile has four chambered heart. Okay, yes. This much clear? This is three chambered. Three. This is two chambered. Okay, now aves and mammals have proper four chambered heart. Proper four chambered heart. Students, what is the difference between aves and that is birds and us is that for us our aorta goes from the left side. Okay, aorta moves to the left side to supply the blood to all the parts of the body. But for birds, it goes to the right side. That is the only difference. That is the only difference in both of our hearts. Okay, this is my left side, so it becomes the right. Okay, this is my right side, so that becomes the left. Always make the demarcations very, very clear. Okay, so here what we have? Here this two we have four chambered heart. Okay, yes. Okay, so now what's actually happening, students? Now let's draw this fish fish heart, magnified fish heart. Okay, magnified fish heart. Yes. So what is happening, students, in fish heart, when we speak about the heart of the fish, it is basically coming like this. Okay, like this. 1, 2, 3, 4. Okay. Here also it's coming 1, 2, 3, 4. Okay. So here we have auricle. Here we have ventricle. Here we have con arterios. Here we have sinus arterios. Okay. Sorry, sinus venosus. Sinus venosus. Now what is happening? All of you focus. Here you imagine body. Okay, here you imagine gills are. Okay, all of you try to understand. Try to understand. Yes, crocodiles have 4-chambered heart. Okay, that is an exception. Difference. Oh, difference here. So aves and mammals, no, the same heart. They have 4-chambered heart. Now what's happening, no? Iota, when I draw the heart, you will understand. Iota is going to the left side. Left side for us it is going. Instead for birds, it's going to the right side. Okay, going to the right side. I'll show you the diagram. Do not worry. Okay, students, now look here what is happening. From the body, deoxygenated blood will enter. Okay, I think I should use blue color, no? Blue color we'll start using for all deoxygenated. Yeah. Okay, students, look here. Respiration happens, right? Respiration happens. So, from the body, deoxygenated blood will enter inside. Okay, inside the fish. This is fish heart. Okay, now this blood will enter. It will go to the sinus venosus. It will go to the auricle. It will go to the ventricle. From there, it will go to the conus arteriosus. From conus arteriosus, it will go to the gills. Now, what is gills going to do? Gills is going to do the job of oxygenation. Okay, gills are going to do the job of oxygenation. Got it, all of you? Can you all see the color? Yes or no? Okay, oxygenation is done by the gills. Now that will be transported to the body. So how many times is blood circulation happening in fish? Only one time, right? Only one time blood circulation is happening. Any doubts in this? Any doubts in this? No, right? Easy? Easy? Yes. Single circulation. And students, what kind of blood is going throughout the body? Deoxygenated blood is going. See, deoxygenated blood is entering. It is going through the fish body and it is coming to the gill. Then it is getting oxygenated and it is going, right? So this kind of circulation is called as venous circulation. Okay, venous or US circulation. I mean, sorry, this kind of heart is called as venosus heart. Okay, venosus heart. Clear or not? Clear or not? Single circulation. Yeah, this is the heart of fish. Heart of fish. Yes. Now let's try to understand the amphibian heart. Okay, let's try to understand the amphibian heart. Okay. Yes, let's draw this box. Okay, I cannot draw box, I understood. Okay. So look here, we have right auricle, left auricle and only ventricles. Now what is going to happen? You have to understand the pathway. Okay, pathway you understand. See students, when we talk about your amphibians, you know they are poikilotherms or cold-blooded animals, right? Why do we call them cold-blooded animals? We call them cold-blooded animals because mixing of blood is happening, right? Mixing of blood is happening. So what is happening actually here? Deoxygenated blood is entering the right auricle, correct? Okay, here it is getting mixed up. Okay, some amount is getting mixed up here. Then again, if you see here, oxygenated blood is coming in. Okay, here oxygenated blood is coming in. That is also getting mixed up. Now this mixed blood, that means which is come from the right auricle, which is coming from the right left auricle, both are going to get mixed up and both are going to go to the body. This mixed blood is going to go into the body. Clear or not? Clear or not? Yes, correct. Very good. Incomplete circulation. This kind of a circulation is called as incomplete circulation. Because what is happening? Blood 2 times it's entering, right? 2 ways it is entering. One from the right and one from the left. One is oxygenated, one is deoxygenated. Now both this mixed blood is going to go through the entire body, because of which these are cold-blooded animals. These are cold-blooded animals because they don't have the energy to regulate. Their energy is low, right? Only and the organism which has proper energy can ever regulate, can do this regulation. Clear or not? Easy? Easy? Yes. Yes, it is incomplete circulation because completion has not happened. Ventricles only. First of all, they have 3 chambers, right? So, this is your amphibian heart. Okay, amphibian heart. Clear? Can we go to the next one? Human heart. Yes, we have reached human heart. Okay, students, 1 second. Let me check. Yeah, okay. Human heart. So, before we start the heart, let's understand the wall of the heart. How is the wall of the heart made up of? Clear? Okay. Wall of the heart is mainly made up of 3 layers. Okay, let's start the outer layer. There'll be outer layer, middle layer, and inner layer. Correct? There's an outer layer, middle layer, and an inner layer. Now, this outer layer, middle layer, inner layer. This outer layer is made up of epicardium. Epicardium. Middle layer will be made up of what? M only it should start. Myocardium. Correct? Myocardium. Okay. Inner layer is made up of what, students? Come on, tell me. Endocardium. Right? Easy. Endocardium. So, we have epicardium, myocardium, endocardium. Clear? Now, students, this epicardium itself has 2 parts. It has 2 parts. Okay, what are those 2 parts? 1 second. Yes. Those 2 parts are serous pericardium, serous pericardium. Okay, and we have fibrous pericardium. Fibrous pericardium. Okay, got it? Okay, yes or no? Pericardium, epicardium has 2 parts, serous pericardium and fibrous pericardium. Now, myocardium has only 1. Okay, that means, students, we are just talking about what is this made up of, like what is it made up of and all that. Myocardium, myo means what? Okay, muscles, right? It is made up of cardiac muscles. This layer is made up of cardiac muscles. Then we have endocardium. Are you all getting so far? Are you all getting so far? Endocardium is made up of simple squamous and epithelium. Okay, it is made up of simple squamous epithelium. Simple squamous epithelium. So, we have pericardium, epicardium, myocardium, endocardium. Epicardium has 2 parts and myocardium is made up of cardiac muscles. Endocardium is made up of simple squamous epithelium. Okay. Okay, now we will draw the structure and I will show you. Okay. We will draw the structure and try to understand. Okay. Let's make it different color. Okay, let's start with blue, students. Okay, now let's draw endocardium. Okay. This is our endocardium. Okay, this is the endocardium. What is this portion called? Endocardium. What is it made up of? Squamous epithelium. Okay, endo. Fine. Now, next layer. Let's draw the next layer. So, the next layer will be what? Myocardium. Myocardium. This is how myocardium will be there. It will be just like as if like you can just scratch that it will look. Okay. Yes. This is your myocardium. Myocardium. Okay. Clear? Fine. Then let's draw with green. Okay. Then we will have 1 layer like this and 1 layer like this. Okay. Now, this first layer which is outside, okay, first layer which is outside is called as your visceral. Okay, it is called as your visceral pericardium. Now you'll be like, ma'am, you didn't tell about this. Students, the serous pericardium is again divided into visceral and parietal. Okay, clear or not? These are all just classifications. Okay, there's no explanation needed. Just understand this first part. Okay, inside part is called the visceral pericardium, and this outside part, this one, okay, outside part is called as your parietal pericardium. Okay, parietal pericardium. Clear? Yes? Yes, no problem. Okay, yes. Students, between this visceral pericardium and parietal pericardium, we have a fluid which you people have been studying for a very long time. Okay, the fluid is nothing but your pericardial fluid. Okay, between this we have something called as your fluid called as your pericardial, okay, pericardial fluid. Pericardial fluid. Okay, the fluid is pericardial fluid. Now, after this also, we have one layer, right? We forgot about our fibrous pericardium. So, you draw like this, okay, draw like this, and just draw like this. Okay, just draw like this. Just this one. This is your fibrous. Students, we'll take this chapter once again on the board, okay? Not now, later, okay? Because I want to draw all of these diagrams neatly so I can send you the notes. Yes, correct. Okay, this pericardial fluid will actually help as a shock absorber. Shock absorber. Got it, all of you, the layers? So first we have endocardium, then we have myocardium, then we have visceral pericardium and parietal pericardium, which will actually constitute your serous pericardium. Okay. Serous pericardium. Yes or no? Clear? Okay, it's visible. Okay. Yes, this is your wall of the heart. Any doubts? Any doubts so far? No, right? Next we will be learning the internal structure. That's why. If you have any doubts, you should ask me right now, right away. Okay, students, this pericardial fluid, it also acts like a lubricant. It also acts like a lubricant. Clear? Okay, fine. Now, heart. So when we draw the heart, now let's try to draw the heart first. Okay. Students, I will take some time to draw the heart. By then, you also, all of you draw. I want all of you to also draw the heart with me. Yes. So it is little tilted to the left. Give 1 second. This bending we don't want. Yes. Yes. Okay. Yes, if you draw like this. Yes, okay, done. Okay, now one layer I did. Now inside layer I'm going to do. Okay, students, the inner layer. Okay, this is the outside layer. It is a little triangular. All of you can draw. So students, inner layer is not that perfect. Okay, it has little waves and all that. You know, none of our body parts are as perfect as we see in the diagrams. Okay, and from here there are going to be some bends. Okay, some grooves kind of structures which we will label. Okay, and if you come here, there is an ridge kind of structure again, like a C, like a small C, and then we have some valves, and then we continue like this. Okay, got it? Again, look here. Again, you have a C here. I'll tell you what is that C I'm talking about. Again, look here. Here you have a valve. Here also you will see ridges. Okay, up and down there will be ridges, which will go like this, and you go like this, you continue like this. Yes, Heart basic done. Okay, basic done of the heart. Did you all draw it? I think all of you are still drawing. Okay. By then. Okay. First, I will start, students. Now, first, I will start with the veins which are coming, right? I'll draw the vena cavas. Okay. So, I'm going to draw the vena cavas here. Look here. This is your superior vena cava. Yes. Yes. Please continue drawing. No problem. You don't have to reply. Here, I'm going to draw my inferior vena cava. Okay. Inferior vena cava. Yes. Here, I will draw my pulmonary veins. Okay, pulmonary veins, 2 of them. Students, if you learn this diagram, your internal structure of the heart also will be done. Here also there will be pulmonary veins which comes from the right side, which we cannot see because it will be back side, right? Which we cannot see. So it will come and there will be 2. So 4 pulmonary veins will be there. Okay, yes, fine, done. Yes, okay, fine. Now, let's start drawing other parts. Okay. Now, see here, students, here there is an opening. Okay, this is an opening. Okay, here, which is called your coronary sinus. Okay, I'll start labeling. Are you all done? Okay, are you all done? Can I start labeling? So, students, this portion is called your superior vena cava. It means which is collecting the blood from the top portion of the body, right? Superior vena cava, also called as pre-caval. Pre-caval. That means which is collecting blood from the top portion of the body. Then who is collecting blood from the lower portion of the body? Inferior. Okay, inferior vena cava. Vena cava. That means what, students? Post-caval. Post-caval. So one is collecting blood from the lower part of the body, one is collecting blood from the upper part of the body. Inferior, superior vena cava, done. Now, students, the superior vena cava is angled at a position that there is no backflow of blood that is going to happen. But when it comes to inferior vena cava, no assurity that backflow of blood cannot happen. So in that case, what is going to happen? I am going to give valves here. Right, I'm going to give valves here because what if blood comes back? Simple. What if blood comes back, right? So that's why these valves are present. Now these valves are called as valves of Eustacia. Valves of Eustacia. Clear or not? Okay. Thank you, Laharika. Okay, students, look here. This valves, why did I give valves for inferior vena cava? Because it is downwards. What if blood comes back, right? This is my right auricle. This is my left auricle. This is my right ventricle. This is my left ventricle. What if the blood comes back? That's why we have kept a valve which is called the valve of Eustacia. Clear or not? Why have I not given valve for superior vena cava? Because it is angled at such a position that the blood will not go back. Okay, blood will not go back. Fine. Now this much is clear. I am doing very slowly the labeling so that you people are very clear. Now I have drawn a red color circle here. This red color circle is called as coronary sinus. That means what, students? It is called as coronary sinus. That means it, you know that heart is also an organ. Because heart is an organ, right? Heart is an organ. It has to supply blood for itself, correct? Because heart is an organ, it needs blood for itself. So the blood that is used up by your coronary, given to your cardiac muscles, to the heart muscles, will come out with the help of this coronary sinus. Coronary sinus. This coronary sinus also, blood can go backwards. Yes or no? Blood can go backwards. So to prevent the backflow of blood, I am going to give some valves here. Okay, I am going to give some valves here. What are these valves called as? These valves are called valves of... Okay, students, this is a little fancy name, but you can definitely remember. Okay. Okay, got it? Okay, test back. So the valve which is present on the coronary sinus. Okay, valves of Thesbacia. Okay, yes. Now this is clear. Okay, this much clear. This part we have done. Okay, now let's come slowly. But here we see some ridge kind of structure. That also I have to label. How can I not label? Right, this ridge kind of structure which you see here, this small curve circular structure which you see here is called as fossa ovalis. What is it called as? Fossa ovalis. Now I'll tell you, students, look here. Let me label it first. Students, fossa ovalis. This fossa ovalis is actually a remain or a scar of foramen ovalis. That means when the embryo stage, mixing of blood happens during the embryo stage. Okay, as the fetus grows, right? As the fetus grows, what happens? This fossa ovalis closes. That means this foramen ovalis will close. Okay, that is why mixing up of blood does not happen as the embryo is growing. But in some cases, in some kids, you would have heard the term as hole in the heart. Okay, there was one of my neighbor, actually her child passed away because of the hole in the heart. I think that time I was in 8th standard or something, so I could not understand what is this hole in the heart. So I really thought there was like they had drilled a hole in the heart. Okay, I really thought there was a hole, like, drilled in the heart. But that's not a hole. That is because here this foramen ovalis has to get closed. Otherwise, mixing up of blood will happen. When that foramen ovalis does not develop into fossa ovalis and the closing does not happen, mixing up of blood will happen, which is termed as hole in the heart. So what is it? It is a remains or a scar of foramen ovalis. Clear or not? Is this clear? Is this clear? Okay. Yes. Now, let's see. Okay, let's see. Students, one part I will be doing. Do not worry. Okay, I'll tell you where every valve is present. Okay, now, students, this one, what did I tell? This, these are pulmonary veins, right? There are four. This two also are pulmonary veins, okay, which we cannot see because it comes from the right side and it will open there. Okay, it will come from this side and it is just opening there. Clear or not? Okay. Now, sorry, between two auricles, this portion between two auricles is called as interauricular septum. Anyone has doubt in this? Interauricular septum. Between two auricles, we have interauricular septum. Okay, between two ventricles, what do we have? Interventricular septum. Ventricular septum. Yes or no? Okay, interventricular septum. Yeah, okay, fine. Now, students, look here. Be very careful. Now, from here, a little complicated parts we are going to see. Now, students, here, which you see, this extension which you see is your tricuspid valve. That means between your auricle, that is your right auricle and right ventricle, there is a valve called as your tricuspid valve, right? All of you know this tricuspid valve, or we can call it as right auriculoventricular valve. This one, this portion here is your right. This is just to make it easy for us, okay? If you see 3D, it will look different. Right auriculoventricular valve or the tricuspid valve. Tricuspid valve. Yes or no? Yes. Okay, this is our right side. This is our left side. Okay, however you're sitting, you should see yourself. So students, why is it called the tricuspid valve? Because of it has three openings, right? Like this. It has three valves like this, right? It has three slits. Okay, it has three slits. That is why it is called as tricuspid valve. Now, if this is tricuspid valve, don't you think this is your bicuspid valve? Yes, this can be a bicuspid valve. All of you agree? Bicuspid valve or your mitral valve. Yes? Yes? Got it. Okay. Great. Okay, no doubt in the diagram, no? So this looks very, very unclean. Okay, so I'm just going to make it second. We'll just, yeah. Okay, clear? Yes, this is bicuspid. That means two open, just two slits are there. Okay, fine, that is done. Now, students, do you see this? I have drawn like this, the villi joint, kind of a structure like a folding I have drawn. So, look here, this larger portion, that means the bigger wave, right? When you draw a wave, what does it happen? Like this, right? That bigger part of the wave or the larger part of the wave is okay, wait 1 second. Papillary. What is it called as? Papillary muscles. Okay, papillary muscles. Students, actually, I wanted to draw a better diagram, but with this pen, I cannot do that much. So please adjust with the diagram that I have drawn. Okay, yes or no? Students, this larger, this big wave that you're seeing is your papillary muscles. Very good. Okay, and the smaller wave that you're seeing, no, the smaller portion, like I will just label this. This is called as your columina. Columina. Okay. Yes, papillary muscles. Any doubts? No, right? Any doubts? Small ridges. Okay, we can say small ridges. They are called as columnal chanae. Yeah. Okay, got it. Students, you will have chemical coordination. From my part, chemical coordination will be there and body fluids. Today's chapter and tomorrow, the chapter which happened. Okay, body fluids and circulation, because I thought I will take it on Thursday. I thought it will give you enough time to revise. But now you will have to immediately write this exam after the live. Okay. Thank you so much, students. People are so sweet. Okay, columnate. Okay, students, now look here. Why do we need this papillary muscles and this chanae? Why? Because this papillary muscles will connect. Okay, this papillary muscles will connect to these valves to form chordae tendineae. Now, what is this chordae tendineae? They are actually structures which prevent the backward flow of blood. Okay, now which color will I choose? I always have problem with color. No, students? Yes, students, look here. This papillary, this larger portions will connect to the valves like this to form chordae tendineae. Okay, they will form like this chordae tendineae. Both the sides they will be present. Okay, can you see here like this? Okay, here also I'm drawing one just to show you. That means to prevent the backward flow of blood. Please write the function, because if I write function and everything, it will look very messy. So that's why I'm not writing. Okay, what is it called? Chordae tendineae. Okay, chordae tendineae. Okay, so it will prevent the backward flow. What is happening if the valves are opening? Blood is coming. What if it flips, right? What if it flips? So because of that, this chordae tendineae will make sure that this valves does not flip. Okay, it will keep the valves in position. Clear or not? Yes, easy. Easy. Or not? Difficult? Yes, okay. Students, we also have semilunar valves, right? We have semilunar valves, right? That is in your pulmonary artery. Now, the problem is, if I draw pulmonary artery, I don't know if it is going to look bad, right? Let me try, students. I will try drawing it. So, students, pulmonary artery starts from here. That means the blood has to enter, no? Now, what is going to happen? All your deoxygenated blood will start entering your right auricle. Anyone has doubt in that? Right auricle, your deoxygenated blood will enter. It will go to the right ventricle, right? Right ventricle. Now, I will teach you the function. Do not worry, I'll teach you the function in a different way. Now, purified blood, okay? Imagine like this way. Okay, blood is going downwards. Okay, now what is happening? Our blood has to be collected from here, right? It has to go to the lungs. It has to go to the lungs for purification. That who is going to do? Who is going to do? Come on, tell me. To the lungs, who is going to take, students? Pulmonary artery has to take. Okay? Yes. So, students, what is happening? Pulmonary artery will have to carry the blood from this right ventricle to the lungs for purification. So, I'm going to draw it here, which is a very big risk because it is going to cover my heart. Okay? And it is going to branch like this. Okay? It is going to branch like this. Who is going to branch? Pulmonary artery is going to branch. Can you see? Okay. Yes. Okay. Somewhat I did, students. It's not perfect, but yeah, somewhat we did. Okay. Okay. Somewhat we did the pulmonary artery. It spoiled my heart, but it's okay. Pulmonary artery. Okay. Yes or no? Now, pulmonary artery is going to take the blood to the lungs. Now we have aorta, right? After purification, blood is coming to the left auricle. From here, one person has to take it, no? Yes or no, students? One person has to take it. So, from here, your aorta, right? From here, your aorta will be going. I told you about the bird and this one, no? Now you'll understand. Why did I tell about it? Yeah? No, I don't know where to draw this aorta. Yes, students, it will go like this. Okay, it will go like this. And it actually branches into 3 branches. It branches into 3. Students, is the diagram too messed up? Or can you understand? Okay, it will branch like this. Okay, this is your aorta. This is your aorta. Aorta will take the blood. So did I tell you, for our body, it goes to the left, right? For our body, aorta is going to the left. Okay, this is the aorta. This is the aorta. Now, students, in pulmonary artery also, backward flow of blood can come. Okay, backward flow of blood can come. So to avoid that, we have semi-lunar valves. Okay, we have semi-lunar valves. Yeah, even I don't have space for aorta, but I adjusted it in this heart. If someone sees this heart, they will get a cardiac arrest after just looking at the heart. So students, here down I'm taking, okay. Here we have semi-lunar valves. Okay, semi-lunar valves. Clear? To prevent the backward flow of blood from the pulmonary artery. Did you all understand? Understanding is important, students. Forget about the neatness of the diagram. Understanding is important. Understanding is important. Okay? Yes or no? Clear? Yes. Not bad. I did so much with the pen. Okay. Students, if you look here, your cardiac muscles are actually thicker to one side. Okay? That means it is 3x times more thicker in the left side. Okay, that is compared to your right ventricle, this side is more thicker. Okay, yes. Students, I am thinking I will sit for some time because I feel tired. Okay, let's sit and continue the class. Yes, 1 second. Let me see myself, how I look. Is it okay for all of you if I sit? Okay, wait. Students, can you still... Wait, I don't think you can see me, no? 1 second. I'm just figuring out it. Yes, I think I'll bring it more down. Yes, 1 second, students. I'm just still finding it out how to. You can see me? Yes, okay, thank you. Yes. I'm visible. Yes, okay. I fixed the chair also. Okay, students, thank you so much. Okay, let's continue. Yes, I'm seeing myself, students. That's the delay. Yes, clear. Okay, students, what is happening? Look here. Here, the aorta is carrying the blood from the left ventricle, correct? Why? Because see, deoxygenated blood is coming. Don't worry, I'm going to teach you the system again. But if I am going to tell you, okay? Yes, if I'm going to tell you about the system, students, understand. Here we have your right auricle, right ventricle, left auricle, left ventricle. So what is going to happen? Here the deoxygenated blood is going to come in, and it is going to take it. Pulmonary artery will take it to the lungs. Then here, after the lungs gives the oxygenated blood, is going to come to the left auricle. From the left auricle, it is going to come to the left ventricle. From the left ventricle, who is going to take? Aorta is going to take. Got it or not? Aorta is going to take. Clear? Yes? Okay, fine. Now look here, look at this heart. Okay, aorta, students, aorta will break open into 3 parts. Okay, 3 parts. Fine. Are you all with me on this? Yes, okay. Students, look here. Let's try to understand. We have lungs. We have who? We have lungs. Okay. We have heart also, right? We have heart. So we are going to draw our heart into this 4 box. We're just going to draw the heart into box. Okay, box, yes. Right auricle, right ventricle, left auricle, left ventricle. Yes, okay. Now here we have who? We have tissues. We have tissues or whatever, body parts, right? Body. Now students, I'm not teaching you double circulation. I'm just teaching you functioning of the heart. Okay, all of you focus here. All of you focus here. Keeping the structure of the heart to one side, you try to understand this. What is actually happening? Tissue is doing respiration. Tissue is doing other kind of functions. Now this tissue will get, that means it is going to have deoxygenated blood, right? Now that has to be purified, right? That has to be purified. So it has to go to the lungs for purification. But what is happening? We have heart in the between. Tissue and lungs were supposed to communicate, but heart is sitting in the between. So we cannot ignore heart, right? We have to still, tell heart, okay, that I'm going this way. I have to come this way, right? Even if you don't want to tell your parents where you're going, you have to tell because you're staying with them. Same way, this tissue and lungs were supposed to talk, but this heart came off in the between because mainly heart came because why, students? Heart is a pumping organ. Such a big human, how will the blood reach till the head? How will the blood reach till a 6 feet, 5 feet, 4 feet person if there is no pumping? If water has to go from the tank to the sump, right? From the tank to the sump, then definitely we need a pumping organ, right? We need a pumping organ. So, now what is happening, students? Understand. From tissue, okay, let's draw blue color for deoxygenated. Okay, let's draw blue color. From tissue, the blood is going, okay, going all the way till your right auricle. Got it or not? Easy, easy. Blood is going till your right auricle. From the right auricle, the blood will move to the right ventricle. Any doubt in this? Any doubt in this? It will move to the right ventricle. Okay. Is it going to go back to the tissues? No, it's not going to go back to the tissues. Yes. Now students, between who? Your right auricle and right ventricle, we have a valve. What is that valve? Auriculoventricular valve or your tricuspid valve. This valve will have to open for the blood to move. Yes, this valve had to open for the blood to move. Clear or not? Clear or not? Yes? Okay. Now students, this valve will open and the blood will come in. Now what has to happen? From the right ventricle, the blood is going to be taken with the help of pulmonary artery. With the help of pulmonary artery, the blood will be taken to the lungs. Now you will be thinking, why did they do this double work? They did the double work because tissue cannot directly pump it to the lungs. We need a pumping organ, right? We need a pumping organ, right? So for that to happen, we need the pulmonary artery. So who is doing this job? Pulmonary artery. Got it, all of you? Now, yes, clear? Very good. Pulmonary artery. Now, students, from the lungs, what is lungs going to do? It is going to purify. It is going to do oxygenation. Yes, it is going to do oxygenation. Now, from the lungs, the purified blood will come to the left auricle. From the left auricle, it will go to the left ventricle, and here which valve will be present? Bicuspid valve will be present. Now is it easy? Now is it easy, students? Here which valve is present? Bicuspid valve is present. Okay, bicuspid valve is present. Okay, and it is going to the left ventricle. Now from the left ventricle, who has to take it to the aorta? Who will take it to the different parts of the body? Aorta, correct? Aorta will come and take it to the different parts of the body. Is it clear? Easy? Easy? Yes, the oxygenation have happened here. Okay, oxygenation has happened here. Yes, very good. Clear? Clear? Easy, no? Easy. So look here, students. How many times is the blood going? The blood is actually going 2 times, right? 2 times. One time deoxygenated blood is going. Second time oxygenated blood is going. So it is going 2 times. 2 times leading to double circulation. Double circulation. Yes? Clear? Okay, double circulation. Okay, semilunar valves are here on the pulmonary artery. Students, look here. Can you see here? Semilunar valves here. Can you see these valves here? I think all of you can see my cursor. Yes, all of you can see my cursor. Yes or no? Okay, so let's understand this diagram also. Semilunar valves are present on the pulmonary artery, so there is no backward flow of blood. Okay, see, look here. This is your tricuspid valve between your right atrium and right ventricle, tricuspid valve. There is one more valve between the left atrium and left ventricle, bicuspid valve. Then there is one valve here on both students, on aorta and the pulmonary artery. One valves are there. This valve is called as the semilunar valves of the pulmonary artery. Then we have semilunar valves of the cystic aorta. Clear? 2 semilunar valves are present, one on the aorta and one on the pulmonary artery. Yes, very good, very good. So all the valves we understood. Then there are valves on the inferior vena cava, which is called valves or eustachian. Then we have one on the coronary sinus. Okay, yes. Now students, I am going to make you write something. All of you write with me. All of you write with me this. Heart is clear? Did I make it easy? Did I make it easy, or is it still difficult for you people? Is it easy or difficult? Clear? Now students, blood has to go from tissues to the right atrium. Okay, blood has to go from the tissues to the right atrium. Now for that blood, that means the blood is going to the right atrium with the help of superior vena cava, inferior vena cava. Okay, inferior vena cava. Yes, and students, it is also going from coronary sinus. That means from the heart itself, deoxygenated blood is going, right? With the help of coronary sinus, the blood is going to the right atrium. Clear or not? Yes, easy. Now students, after this, it will be very, very easy. After this, very, very easy. So focus here, all of you. Now students, from the right atrium, it has to go to the left ventricle. Okay, I'm telling the same thing only. Sorry. From the right atrium, it has to go to the right atrium. Right ventricle. What is happening? Mouse work. Yes, 1 second. Yes. Yes, it will go to the right ventricle. Now, between these two people, that means your right ventricle and your this one, we have who? We have, I'm writing it just for you students, okay? So you feel like, oh my God, it's so easy, heart is. All people were complicating this. Okay, tricuspid valve. Now from the right ventricle, it will be going where? Where will it go? Yes, all of you. Students, from right ventricle, it has to go to the lungs. It has to go to the lungs. And who is going to help your pulmonary artery? Pulmonary. Students, seriously, if my teachers taught me this way, no students, I am serious that I would have, I don't know, I would have got full marks in bio. Okay, in my 12th, I had I think I had somewhere in 88 or something was my score. I would have got 100 if my teachers would have taught me this way, but they could not. Okay, so students, pulmonary artery. In pulmonary artery, we have semi-lunar valves. Okay, to prevent the backward flow of blood. Okay, got it, all of you? Now, from the lungs, what is happening? Here, lungs deoxygenation is happening. That means oxygenation is happening. Why am I saying deoxygenation? Sorry. Full technical issues coming. Yeah. Yes. Oxygenation. Students, oxygenation is going to happen. Okay. Oxygenation is going to happen. Yes. From the lungs, it is going to do oxygenation. Okay. Oxygenation will happen. Now, who is going to collect from the lungs? Aorta will collect. Aorta will collect. Aorta also have semilunar valves. Okay. Now from this aorta, it is from the lungs, students, lungs, it will go to the, one second, sorry, I'll write aorta down later. Okay, lungs, it is going to the right, it is going to the left atrium. From left atrium, it is going to the left ventricle. Yes or no? Yes or no? Okay, it is going to the left ventricle. Now, students, between this, who is there? Bicuspid valve is there. Bicuspid valve is there. Okay. And from the left ventricle, it will go to the body or to the tissues with the help of aorta. Sorry. Okay, little confusion happened. Okay. Yes. Got it or not? Clear? Easy? Yes. Any doubts so far? Any doubts so far? Students, pulmonary vein also will collect and give, right? Yes. Pulmonary vein will do what? Veins always collect deoxygenated. That is why your veins, whenever you have doubt, no, look at this color of the veins. It is green color, no, that means deoxygenated. Blue color. Yes, easy? Easy peasy? Okay, fine. Let's go. Students, double circulation, very easy, students. Look here. Look here. Whatever is going, okay, I'll draw it here only. Look here, all of you. Whenever blood is going from lungs to the heart and from hearts to the lungs, this is called as pulmonary circulation. What did I say? Lungs to the heart, heart to the lungs. Okay. Then tissue to the heart, tissue to the heart, heart to the tissue. This is called as systemic circulation. Okay. How am I telling this? Look here, all of you. From lungs to the heart. All of you think and tell me, lungs to the heart. What is going? Oxygenated blood is going. From heart to the lungs, what is going? Deoxygenated blood is going. Yes or no? Yes or no? Yeah, veins are blue color, students, but you cannot see blue color. No, only very fair people, like very, very fair people, you can see blue color. Otherwise, you can see greenish color. No, that's why. So, green means bad, deoxygenation, like that you should think. Okay, students. So, what's happening? Lungs to the heart, oxygenated blood is going from pulmonary vein. From, what is this? Heart to the lungs, what is happening? Deoxygenated blood is going with the help of pulmonary artery. Tissue to the heart, deoxy. Heart to the tissue, oxy. Correct? Yes or no? Yes. Students, I missed one point. Lungs to this one. No, lungs to this one is your pulmonary vein. This is one point I missed. That's what I was thinking. Something I missed. Student, lungs to the left atrium. Who is going to take? Pulmonary vein is going to take. Right? This portion, pulmonary vein is going to do the job. Okay, this is the step that I missed. Yes. Now, students, tissue to heart, deoxygenated blood is going with the help of whom? With the help of vena cavas or your great veins. Okay, with the help of vena cava, right? from heart to the tissues, that is oxygenated blood is going with the help of aorta. Okay, yes. 1 second. Now let's write what kind of circulation is this. This is called as pulmonary. This is called as pulmonary circulation. This is called as systemic circulation. Easy. Easy. Yes. Okay. Yes. Done. Done. Are we done? Are we done? Or only I am done? Students, are we done? See, we did systemic. We did double circulation also. Is it easy? Is it easy? Yes. Easy, easy. Easy or not? Tell me fast. Easy or not? Very good, very good. Easy, no? Easy, right? Okay. Yes, easy, no? Thank you so much. Thank you so much. Okay. Students, pulmonary circulation clear, systemic circulation clear. Don't faint seeing this. Okay, don't faint seeing this. Yes, yes, I'm going to ask you questions. Okay. Let's ask here. Okay, before I start cardiac cycles. Come on, students. The first question to you people. Okay, answer me this. Question number 1. Tissue to heart. Tell me which is the vein that is taking, which type of blood it is taking. Okay, now okay, answer this second question. Okay, 4 questions I'm going to give you. Okay, yes. Very good, very good. Students, please type the whole thing, students. Otherwise, I cannot see the answer. Okay, please type the whole thing. Valve between. Yes, very good, very good. This one answer is what? Tissue to heart. It's deoxy. I think all of you answered. Very good. It is taken by how? By vena cavas. Right? Vena cava is taking it. Agreed? Yes. Ashish, there are actually doctors here. So if you want any doctors from, okay, they can be your doctor. You can be their patient. Yes. Okay. I hope Ashish Yadav got the answer. Okay, you can be their patient. They will be your doctor. Okay, other things you can ask somewhere else. Okay. Yes. Very good. Okay. Students, deoxy, vena cavas. Okay. Heart to lungs. Right? Heart to lungs is what? Tell me. Deoxy. Very good. Deoxy. Who is going to take it? Pulmonary. Artery is going to take. Lungs to heart, what is going to be? Oxygenated blood is going to be taken. Lungs to heart, who is going to take? Pulmonary vein. Yes? Yes? Yes, thank you. That is what Baswa sir told yesterday. He's like, how do you answer spammers? Because I get lot of, spammers, so I have to. What to do? Too good of a class minus that I'm getting spammers, sir. Is that the reason, students? You people should tell me. I don't know. Yes. Went off. Yadav went off. He got disappointed. He's like, this teacher does not let me have peace also. She's talking about heart, but she does not have heart. That is what he thought, no? Yes. Okay, students, done. Now we are going to study another very important. Now, heart is thorough. Will you ever forget heart? Will you ever forget heart? No, right? Okay. Students, see, listen. Mass OP, you will get all the difficult questions in your mock test. Right now, I do not have time for questions. Okay, because we need to finish the class also. And students also will be exhausted who joined at from 5 o'clock. Okay, so students, now we will learn cardiac cycle. Okay, ready cardiac cycle. Students, if you see here, you can see stage 1, stage 2, stage 3. Do not get worried. I'm going to teach you. Okay, I'm going to teach you cardiac cycle. So before cardiac cycle, let me make you understand some word. Students, contraction means, okay, contraction means systole, right? The other word is systole. Now, when I talk about relaxation, okay, relaxation, it means diastole. Diastole, correct? So, in 60 seconds, right, in 1 minute, heart beats 72 times. That means that many cardiac cycles are happening, right? Cardiac cycles are happening. Then, one beat. So, students, one beat is one cardiac cycle. That means 72 cardiac cycles will happen. One beat, one cardiac cycle. So, one cardiac cycle. This is like that math sum, no? X is equal to y is equal to what? Okay, is around 0.8 seconds. Okay, one cardiac cycle is around 0.8 seconds. Clear or not? Clear or not? Yes? Okay. Actually, I used to make one way to remember this when I was in college, but I cannot remember it now. I don't know why. Okay. Yes, got it, all of you. Students, did you see this? Stage 1, early students is very fast, but did you see this? Okay, diastole. Now we are going to learn it. Okay, students, look here, all of you. I'm going to break this circle. Okay, I'm going to break this circle into some parts. Okay, some parts. Oh. Yes. I somehow made it a line. Okay, students, look here. So, cardiac cycle has mainly 3 events. Okay, how many events does it have? 3 events. Mainly, it has 3 events. Okay, in that, the first event, or we can say some of the events, okay, not first event. Let's say first is joint diastole. That means relaxation is happening. Then we have, okay, so here we have arterial systole. Here we'll have, if one artery is happening, down will be ventricular systole. Ventricular systole. Got it, all of you? Yes or no? Yes or no? Yes. Okay. Students, look here. Joint, okay, joint diastole, arterial systole and ventricular systole. Joint systole takes about 0.4 seconds. I told you one cardiac cycle takes around 0.8 seconds. So you can split it. This is 0.4 seconds. This is 0.1 second. And this is 0. How many students? 4 plus 3. You should know the maths. 3 seconds. Okay? 3 seconds. Got it, all of you? Now, let's try to understand each of it. Now, students, arterial systole. Okay, when I talk about arterial systole. Are you all with me? Easy. Let's try to learn it with the circle. Yes? Okay, fine. Students, in arterial systole, what is actually happening is that both here, it is expected. Who is expected? Both the arteries have to contract. What is expected? Both the arteries contract. Both the atria or Both the atria contracts. Not arteries, sorry. Both the atria contracts. Okay, my mouth is going atria contracts. Not arteries, atria. Yes? Students, when both the atrias contract, okay, we will expect it not to close. AV valves have to close. Okay, what am I trying to say? Now imagine this is your heart. Students always learn from box heart. It is better always. Right atrium, right ventricle, left atrium, left ventricle. See students, I'm telling this both has to contract. I will close both the valves, no? We'll close both the valves. Okay, I will close both the valves. So the AV valves will, AV valves will open. Sorry students, sorry. Close, no, open, it has to open, no, because both the valves have contracted. Full pressure will be there, no, so the AV valves will open. One second, I will tell it to you. One second, open. Okay, there's so many. Yeah, now these two valves will open because the atrias have contracted. Now it has to go to the ventricle, so the AV valves will open. Okay, small mistake. Now what is happening when both the atrias contract and the AV valve open? That will lead to the closing. Okay students, that will lead to the closing of a vena cavas, right? Superior and inferior vena cava. Yes or no? Superior and inferior vena cava will get closed. Your pulmonary vein will get closed. Yes or no? Right? Vijay, what is happening? Vijay, what is happening? Please do not spam the class. Okay, students, both the atrias contract, AV valve will open during the atrial systole. Okay, the vena cavas, both the vena cavas will close, pulmonary vein will close. Okay, during that time, what is sound is going to come? Lub, right? Lub. That means closing of the valves, right? Closing of the semilunar valves of the pulmonary vein will lead, right? This closing of the semilunar valves will lead to the lub sound. Whenever a valve closes, the lub sound comes. Yes or no? First, lub sound came. Yes. Then we will go to the ventricular systole. Now, during the ventricular systole, what is going to happen, students? Okay, ventricular systole, what has happened? Both the ventricles have to contract. What else will happen? No? Both the ventricles. Okay, one second. Keep it properly. Contract. Yes. Very good. Okay. Both the ventricles will contract. Okay. Now, students, when both the ventricles contract here, there is no opening. Right, when this both are completely contracted, there is a pressure created. That means no valves are opening and they are like, oh my god, I have to open, like some valve open please, right? That kind of frustration comes, no? That kind of a situation, not a frustration, a situation is called as isovolumetric contraction. Isovolumetric contraction. That means they have reached their maximum. Right, full contraction has happened, no valves are opening, right? That kind of a thing is called as isovolumetric contraction. Clear? Now students, who closed here? Semilunar valves are now here. Semilunar valves will open. Semilunar valves will open. Clear? Yes, very good, very good. Mona. I told you I'll call you Mona, no? Mona, very good. Okay, now after this ventricular systole, like just going before the joint diastole, that means both of them have to relax now. Now they've contracted, they've done their job. Before both of that happen, okay, before both of that happen, here, before entering the joint systole, here you get the next sound, that is your dub. What is the sound? Dub sound. So that is lub dub, right? Okay. Yes or no? Yes or no? Clear? Okay. Dub sound will Okay, this is because of the closing of the semilunar valves. Okay, students, only closing of a valve will make sound. Okay, please understand. Semilunar valves will close. Closing of the semilunar valves will lead to the dup sound. Dup sound. Yes or no? Yes? Fine. Clear. Okay. Now, students, we are going to the JD. What is JD? Joint diastole. Joint diastole means what, students? Both will relax. Both will relax. Correct? Relaxation will happen. Relax. Who will relax? Both will relax. Then what will happen? Closure. Closure of semilunar valves. Semilunar valves. Yes. And students, what will happen? Ventricular filling will happen. Ventricular filling will happen. Yes? Clear or not, students? Clear? Okay. Ventricular filling is actually of two types. Okay, that means two times ventricular filling will happen. One is 70% is filled during the JD, that is the joint diastole. 30% is filled during the AS, that is your arterial systole. Okay, AS. AS is usually faster. Okay, here actually 1/3 will be fast, then it will become slow. Yes, got it? Yes. So this is your cardiac cycle. This is your cardiac cycle. 3 events. Arterial systole, ventricular systole, joint diastole. Arterial systole 0.1 second, ventricular systole 3 seconds, joint diastole 0.4 seconds. Okay, students, shall I ask you a question? Shall I ask you a question? Yes or no? Yes? Ready for a question? Okay. Tell me the gap between, okay, let's say dub. Students, gap between dub and lub. Students, gap between dub and lub. Tell me the gap between dub and lub. Yes. Go for it. Go for it. Answer the question. Wow, 0.5 seconds. How did you people calculate? Students who did a mistake, let me tell you, students, you cannot go reverse. So, dub means you have to finish your joint diastole, then come to your arterial systole, then only lub sound. So, dub and lub is 0.4 plus 0.1. I am so proud of my students. Very good. 0.4 plus 0.1. Okay, you cannot go reverse. Okay, you have to complete this and come here. Okay, so that is how it is. 0.4 plus 0.1, that is 0.5 seconds. Okay, next one is what? Students, it's not 0.3 seconds. It is not this. It cannot be lub dub. It has to go from dub, come back to lub. Reverse you can't go. Okay, next question. How much is the arterial diastole? How much is the arterial diastole? See, arterial systole is 0.1 second. Then how much is the arterial diastole? Come on, tell me all of you. Tell me all of you. Got it all of you? No reverse. Go like this only in circle. Okay. Students, lub to dup is 0.3. Dup to lup is dup to lup is 0.5. Don't get it confused. 0.3. Okay, Rupa, very good, very good. Malar, very good. 0.7 seconds. I'll tell you how. Students, arterial systole is only for 0.1 second. Cardiac cycle is around 0.8 seconds. So 0.8 minus 0.1, that means the rest of the time when systole is not happening, diastole is happening. Correct? So it means what? 0.7 seconds. Yes or no? All of you understood? Understood how I got 0.7 seconds for arterial diastole? Now let's try for this. Tell me ventricular diastole then. Tell me the answer for ventricular diastole. Yes. Ventricular diastole. What will be the answer? 0.8 minus 0.1. Yes, correct. Arterial diastole. Now tell me ventricular diastole. Ventricular diastole. Tricky questions can come for the exam. Tricky questions can come for the exam. Okay. Let's see answers. Let's see more answers. (0.5 seconds. Very good. That means how? 0.8 minus 0.3. Right? 0.8 minus 0.3. Sharad, did you understand now? Did you understand? Okay, whenever ventricular systole is happening, diastole is not happening. But the rest of the 0.5 seconds, diastole is happening. Simple. Simple maths. Yes, did you understand? Any doubts so far? No, right? No, right? Okay. Students, when we talk about LUP and when we talk about LUP, okay, DUP is a longer duration. It is for longer duration. L stands for long. So, longer duration. Okay, that means the sound is for longer duration, but it is low pitched. Okay, it is low pitch. Students, now if you hold your pulse and see, you can hear LUP-DUP sound. Right? LUP-DUP sound. Imagine after 5 years, you will be putting stethoscope and checking. Oh, this person has how much heartbeat, this person has how much heartbeat. Okay? Yes. And it is because of the closure of your AV valves. Closure of your AV valves. Wait, students, did we write that here? Valve closes. Yeah, this is AV valve. Closure of this valve. Okay, AV valve. Yes, okay. Students, closure of your AV valves leads to the LUP sound. Okay, closure of semilunar valves leads to the DUP sound. This is shorter duration. This is shorter duration. And this is high pitch. Okay, everything ulta. And this is closure of your semilunar valves. Sorry, semilunar valves. Any doubts so far? Any doubts so far? Yes. Okay, great. Yes. Okay, now we will understand blood vessels, or we can also understand blood pressure. Students, sometimes LUP-DUP sound, other than LUP-DUP sound, you can hear some other kind of sound. Okay, that is called as heart murmur. That we say heart is murmuring. Okay, why do we say heart is murmuring? Is because there is an abnormal sound that is coming. Okay, so the doctor will understand immediately when they hear an abnormal sound. It could be because actually the valves are not closing properly. Valves are not closing properly, and because of that, what is happening? Blood is going backwards, flow is happening, leaking is happening. That will lead to heart murmur. Okay, that will lead to heart murmur. Clear or not? Okay, students, look here. If you look here, this is how your blood vessel looks like. Okay, this is how your blood vessel looks like. The first layer is your tunica interna. I think that is the word better. Tunica interna. Then we have tunica media. Okay, that means the middle layer. Then we have tunica externa. That means the outer layer. Okay, tunica externa is made up of a fibrous connective tissue with collagen fibers. Okay, and then we have tunica media with smooth muscles and elastic fibers. Okay, then we have tunica interna, which is made up of squamous endothelium. This is how your blood vessels are formed. Now, why am I teaching about blood vessels? Because you should understand that blood exerts a pressure on the blood vessels, especially on the artery, because artery takes the blood to the different body parts. So because when blood is moving with so much pressure, like I have to reach all the cells, they will exert a lot of pressure on the artery. Okay, they will exert a lot of pressure on the artery. Clear or not? These layers are clear. Tunica externa, outer layer, fibrous. Students, whenever you see fibrous, you can see this kind of a structure. Then there is tunica media, smooth muscles. Then there is tunica interna, squamous or the endothelial muscle. Now, if you look here, artery and vein, can you see the lumen is bigger? The lumen is bigger for the veins. Lumen is bigger or wider lumen is you can see in veins. Why you can see wider lumens? Because veins are carrying your deoxygenated blood and the lumens will be bigger, means more blood will be carried. Okay, arteries, if you see the lumen is small, right? The lumen is not very wide, right? Okay, lumen is smaller, but they have thick walls. Why? Because arteries has to take up more pressure. More pressure is exerted by the blood in the artery. Okay, clear? More, to take more blood. Veins will take more blood, right? So more blood can go to the heart. More blood can go to the lungs, right? For the pumping. More blood will be taken if the lumen is more. Wider the lumen. Students, imagine a pipe with this much diameter and this much diameter. Circumference. Okay. So which will take more water? This one will take or this one will take? Which will take more water? This will take more pressure. This will take more water. Correct? Agreed, all of you? Agreed? Yes. Okay, great. Fine. Now, blood pressure. I told you, more pressure is exerted on the artery. More pressure is exerted on the artery because artery is carrying blood everywhere. Okay. So, blood pressure is, checked with the help of sphygmomanometer. What is it? Sphygmomano. So many letters are there in this word. Mano. I'm writing so many letters. 1 second. Yes, sphygmo. There is when there is lot of letters, you get confused if this letter should come first or next letter should come first. That is the problem, right? Even though I'm a teacher, there are some words that are sphygmomano, manometer, right? Sphygmomanometer. Okay, finally I've written, students, with so many letters. Okay, sphygmomanometer will calculate the BP or the blood pressure. Have you seen that? They will tie it around the hand. They will do shh, 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 right? They'll do. So that is how you calculate the BP. Now, how is usually BP calculated? It is with the simple formula. Okay, systolic pressure by diastolic pressure. That's why I introduced this word before to you. Okay, pressure. Now, listen here. It will be 120 mm Hg by how much? By how much? 80 mm Hg. So, a normal person with normal BP, that is BP should be normal, will be 120 bar 80. This is the normal BP. If you have parents during exam time, they will get high BP, right? Now, you will also get high BP during NEET exam, right? On May 4th, you will be thinking, yo, I should have sat that day full day in the heart. When Gopika ma'am was teaching heart, I should have sat full day and learned. But instead, what did I do? I just left and came because I didn't want to study. Correct? Agreed? Agreed, all of you? Yes. Okay. Students, there's also something called as pulse pressure. Pulse pressure. Pulse pressure is actually your SP minus DP. SP is how much? 120. DP is how much? 80. So total will be how much? 70. Correct, students? Maths is correct. You don't have to minus also, I think. Students, maths is wrong. No, 60. 60 is the answer. Maths is very bad. Okay. This is how pulse pressure is. Pulse pressure. Yes? Yes? Okay. 40, huh? So why full maths confusion is coming from? Sorry. 120 and 80 is 40. Sorry. Okay. Yes. 40. Actually, they don't calculate usually, but I'm telling you 40. Okay. Got it, all of you? Then there is something called as the stroke pressure. Stroke pressure. Okay. Stroke pressure. That means at what rate? What rate is each ventricles, passing the blood? Okay. That means what, students? Now you imagine right ventricle, left ventricle. Okay, right auricle, left auricle. Now this ventricle, how much blood are they passing back to your auricles? That is, okay, that is, hello Zen. Okay, that is your stroke pressure. That means the volume ejected by each ventricles during a ventricular systole. That means when the ventricle contracts, and then that time how much blood is going. Okay, shall we calculate? It is usually 70 ml. Okay, if you want to know the calculation, it is basically SV is equal to EDV minus ESV. What is EDV, students? End diastole volume, and ESV is end systole volume. Sanvi, that means you have to consume more salt. Your salt content is less in your body. Yes, correct. Blood pumped during each veins during a ventricular systole. Okay, ventricular systole. Yes, students. So, end diastole volume is usually 130, and end systole volume, that means after the blood going to the auricle also, how much do they have? That is will be 60. That will give us 70. Okay, that will give us 70 ml is actually sent to the auricles. Clear or not? Yes, problems, maybe one like this, one simple problem could be asked. Not very complicated, but simple problems can be asked. Okay, simple problems can be asked. Yes? Okay. Then cardiac output. Cardiac output. Yes? All of you are with me? Cardiac output. How much is cardiac output? 5040 ml. Students, how is it calculated? This stroke volume into heartbeat. Easy. Stroke volume into heartbeat. Okay, I feel like I've become a maths teacher suddenly, but I know I'm not. Okay, I just feel. Feelings are normal, right, students? Feelings are not real. So 5040 ml, which is around 5 liters. Okay, in athletes, they will have 25 liters to 30 liters capacity because they have made their heart into that capacity. We'll have 5 liters. Got it, all of you? Yes or no? Okay. Now, who regulates the heartbeat? You'll be like, huh? What are you asking, ma'am? Who regulates the heartbeat? It's not the brain. It is something called as your nodal tissue. Who regulates the heartbeats? Nodal tissue. Now, students, you will be like, what? Nodal tissue? Then what about the brain? Students, brain does not regulate the heartbeat. Heart itself regulates the heartbeat, and there are certain muscles which are nodal tissues, which are made up of your cardiac muscles. They will, okay, muscles will actually regulate the heart. Okay, regulate the heart. Yes. So, now let's just draw a dummy heart. Okay, dummy heart. Yes. Okay, this is how your heart is. Okay. Yes. Now, look here. Let me make the separation. Oh, separation went off somewhere. Right auricle, left auricle, right ventricle, left ventricle. Okay, done. Now, students, look here. All of you look here. We have here one person is there. Here one person is there. Okay, these two people. Other than these two people, there is I think we can draw like this. Yeah, we can draw like this. Okay, like this and like this. Yes. Okay. Yes. Now, students, I'll label. Don't worry. Don't worry. Just try to understand that this is how the diagram looks like. Oh. Today, pen also is cheating on me, students. Yes. Okay. Students, come on. Okay. Students, this is sinoatrial node or your SA node. Sinoatrial node or SA node. Okay. These are the people who are actually controlling or regulating the heartbeat. Okay, this 72 times should we regulate, 100 times should we regulate. Oh, this fellow didn't study anything for the exam, now he is getting heart attack. 100 heartbeats is happening after looking at the NEET paper. Now what do? SA node will be like, okay, do one thing, keep regulating the heart. Let him get nicely shocked. Why didn't he study on time, right? All this kind of regulation is done by whom? Your sinoatrial node. Okay, then you have one more node here. One node here, this node, okay, here, yes, students, okay, which is called as the AV node, which is because it is called AV node because it is present near the auriculoventricular valve. Okay, that is your tricuspid valve. No, it is present there. That is why it is called as AV node. Okay, then from here there is one branch coming which is called as AV bundle. Okay, like a branch structure is coming, AV bundle. Okay, AV bundle. Now this AV bundle is continuing like like tree branches. It is continuing, which is called the Purkinje fibers. We have discussed this in our class, in our neural control and coordination. Purkinje fibers. Okay, Purkinje fibers, right? This Purkinje fibers. Now I have drawn like this one circular structure here. Can you see here? This is called as bundle of His. There is no bundle of her, it is only bundle of his. Okay, we also have. Or even if we are not his, we have. Okay, we have. Okay, yes. So students, okay, suddenly AC is like, okay, let me make it a little more cold. Okay, yes. Got it, all of you? So students, nodal tissue, we have which and all? Sinoatrial node, AV node, AV bundle, bundle of His, Purkinje fibers. These people regulate the heartbeat. What do? They regulate. They regulate the heartbeat. Heartbeat. What is that song, students? Please put it in the chat box. Heartbeat. Not much I know. I only know heartbeat word is there. Okay. Do anyone know the song? Don't tell me people don't listen to Bollywood songs. Only what? Dapanguchi you dance. Yes? Only Dapanguchi people do. I know something. Heartbeat missing something. Why the chat's not moving? What happened? All of you slept off. All of you slept. Students, don't sleep. Don't sleep. We have only little more topic to do. So students, SA node. Oh. Leharika is telling, if you listen to song, we become indecent. I don't know. Is it written in Constitution? Which Constitution it is written that if we listen to songs, we are, these students, you should. No one knows. Wow. Students, there's no song in South Indian with heartbeat. Only some Hindi song is there. Okay. Next time I will learn the lyrics and come. Okay. Yes. Decency and all, people are talking in songs. Come on, students. That much you shouldn't be. Leharika, no. Leharika is very this one. So students, look here. Your SA node is present in the atria. So SA node is given the full control of the atria. Okay. Full control of the atria. So it will actually regulate. Now SA node will send signal to AV node. AV node will send signal to AV bundle. AV bundle will send signal to Purkinje fibers. Okay. So SA node is actually called the pacemaker of the heart. Okay. Pacemaker of the heart. That means it will regulate the pace. It will regulate the pace. Okay. Yes. Constitution is written by Leharika. Right? Okay. I listen to all the language songs, students. I don't have one particular language. we'll have no then when we are listening, suddenly when we are sad, when we listen to sad songs we feel more sad. Then we listen to in between the emotions, if suddenly a Dapanguchi songs plays, you start dancing. So that is all because your heart, your sinoatrial node, everything is playing with you. Okay, everything is playing with you. Your hormones, your oxytocin, your SA node, all these people are playing with you. Okay, now who is the joke? You. Yes, who is the joke? You. Suresh, even I don't know when the class will end, Suresh, but I'm assuming it will end by 9:30. Okay. Yes, students. Done, dusted. Done, done. Let's see one image, one beautiful image. Am I covering the image? No, right? Student, then if I sing a sad song, it will become one Dapanguchi song. Okay, that is the voice I have. With my voice modulation, I'll make it a dance song. Yes, done. Okay, fine. Student, look at this beautiful diagram. Can you see the sinoatrial node? Okay, sinoatrial node. It is going to send signal to the entire atria, right? And then we have this atrioventricular node, which is almost near to this valve, right? Okay, and then from here bundle of the sorry your AV bundle is passing, and can you see how Purkinje fibers are getting spread entire to the ventricles? It is getting completely covered near the ventricles. Okay, ventricles. And from there, right, it is going, see, can you see it is completely covering the going through the ventricles, Purkinje fibers. And then here this is called the bundle of His. Clear, easy, beautiful diagram, beautiful diagram. Yes or no? When I send you the notes, you will be able to see how beautiful the diagram is. Okay? Yes, fine. Now we have reached electrocardiogram. Students, electrocardiogram. First I have to draw one human. Okay, first I will draw one person. Okay. Now let's draw one person. Okay. Yes. Person ready? Okay. Okay, students, person is ready. Okay, let's finish off this chapter. Let's not keep it for another one more break and all not required. Or you people need a break? You need a break? Students, do you need a break or no? Tell me quickly. We have only ECG and we have disorders. We have ECG and we have disorders. That's all. Then we are done with this chapter. My God, we finished the chapter. No need break, no? Yes, good job. Okay. I'll just fill water and come. Okay, by then that is your break. Okay, by the time I fill water and come, that is your break. Because my throat, if I stress too much, doctor, you people only. Like you people, doctors will scold me. Right? I'll just fill water and come, students. Yes. Okay. Since I'm back, are you all back? You didn't go, no? Oh, what is happening? Haha, they started a full family discussion. How is your family? How is your health? 1 minute, ma'am goes, won't read the notes. Ready? Okay. Okay, students, look here. ECG or your electrocardiogram is actually the graph. Okay, it is actually the graph. Okay. So, look here. The graph is called as electrocardiogram. Okay, now what is the instrument called as? Instrument. Instrument is called as electrocardiograph. Electrocardiograph. Got it, all of you? Electrocardiograph. Who was the person who found it? Are you all with me? Yes? Did you all go? Okay. Entowin was the scientist who found it, and he also got a Nobel Prize for this. Okay, for this discovery. Students, what is happening? When an ECG, it has to be done. Okay, they will put one lead here, one lead here, one lead here. Nowadays, actually, more leads have come. They keep one on the chest also. Like now, more than, I think, even 12 leads are there nowadays. But let's just focus on what is given in your NCERT. 3 leads. Okay, now this will look like a triangle. Look here, all of you. This person is little tilted. Otherwise, it will look like a triangle. Yes or no? Looks like a triangle. Okay. Yes. Okay, so students, yeah, so this triangular structure will give us the ECG. Now let's understand what is this ECG talking about. Why am I talking about ECG? Okay, 3 leads. 3 leads means I'm connecting one on their right hand, one on the left hand, one on their left ankle. Okay, left ankle. So by connecting this, I'm forming a triangle, or I'm forming a closed circuit. Otherwise, I can say closed circuit. Today we studied maths, we studied physics, what and all we studying, right? Closed circuit. Okay, students, look here. Now, this is your cardiogram. This is your electrocardiogram. Have you all seen this when you're doing this, when you're in a movie, have you heard this? Beep, that person dies off, right? Beep, 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 that person dies. Have you heard that? Have you heard that? Like, it'll be like this. In the movies, they show like this. Shh, gone. Mar gaya. Right? Got it? The person dies. Okay? Okay. Now look here, students. By then, I will just mark this. Yes, correct. Very good. Laharika. So here we have P. Here we have Q. Here we have R. Here we have S. Here we have T. Okay? Here we have T. Okay, so students, this is how the graph will look like. Now let's try to understand what each of this is talking about. Okay, what each of this is talking about. Students, there is something called as repolarization and depolarization which is going to happen. Okay, repolarization and depolarization, that is going to happen. Okay, clear, all of you? Now, first, when if P has to happen, then there should be an arterial depolarization. What has to happen? Atrial depolarization. It is like a stimulus. If atrial depolarization have to happen, if that happens, then only atrial systole will happen. This you will study in depth when you go to MBBS and all. Like when you do your first year and all, no, you will understand a lot about it. Like how this depolarization is happening, what is the ion exchange happening, that you will learn. Okay. Now, if this depolarization is like your stimulus, that means if I raise my hand, you will move like this, right? That is the stimulus. Then that will lead to atrial systole. My tongue is twisting, students. After 4-5 hours, no, your tongue will be like, why are you talking so much, right? That is the situation now my tongue is facing. Okay. Yeah. Here what is going to happen? Ventricular depolarization will happen. Okay, ventricular depolarization will happen. That will lead to your ventricular systole. Ventricular systole. Okay. Okay. Now, this is your R. Okay, this QRS is formed when there is a ventricular depolarization that will lead to a ventricular systole. Now, what is going to happen in T, students? What is going to happen in T? All of you tell me. Students, this QRS, okay, this QRS will let us know the pulse rate. Pulse rate. Have you seen this in movies? Can you see this? This is the QRS. So R is the highest amplitude. Highest amplitude. Got it, all of you? And S is the lowest amplitude. Can you see S is the lowest amplitude? More than Q, S is going little more down. Lowest amplitude. Got it, all of you? Very good, very good. Very good. Repolarization of ventricles, right? Ventricles. That will lead to the T. Right? Repolarization. Very good, students. Very good. Okay. This is how the wave is formed. Is this clear to all of you? High amplitude is R, low amplitude is S. Okay, so QRS will determine the pulse rate. That means counting the QRS, I can tell what is the pulse rate of that person. Okay, pulse rate of that person. Okay, clear? Clear? Okay, fine. Yes. Okay. Now, students, there are some conditions. Okay, there are some condition. Yes or no? There are some conditions. Now, the conditions are that, see, so say this is the wave. Okay, this is your P wave, this is your Q, this is R, and S. S has gone like this. S has gone like this. That means what is happening, students? What is happening, students? Okay, what is happening, students? This leads to myocardial infarction. Okay, myocardial infarction. That means what has happened? P is here, Q is here, R is here, S has gone straight. Instead of S being the lowest amplitude, it just went off straight. Okay, so this will happen. Or in other case, this could happen. Just went like this. Okay, students, what is happening here? P, Q, R, S. Right? S. Clear or not? Is there anyone, any person who did not understand anything? Yes. Ma'am, why there is no repolarization? See, actually, atrial repolarization happens, but the problem is the ECG cannot capture it. In the sense, the magnitude has to be bigger for the ECG to capture it, right? If, see, the wave is so much, the ECG cannot capture it. Got it? Got it? Okay, so for the ECG to capture, the magnitude has to be more, but the atrial repolarization magnitude is not big enough for the ECG to catch. Is this clear? Clear or not? Yes. Okay, fine. Students, here what has happened, students? Here it went straight. Okay, here I have not drawn it. See, I'll show you here. What is happening? Okay, here it is going like this above and it is going down. S is going down. This is called as myocardial ischemia. Okay, myocardial. This is because of lack of oxygen. lack of oxygen. Okay, if this is not treated for a long time, it will become myocardial infarction. That means you will get heart attack. Okay, you will get heart attack. Clear or not? Any doubt so far? No, right? Clear. Fine. Okay. Yes, 1 second. We will do one more topic here, students. That after that, we will do diseases. Students, it is basically regulation. Regulation. Regulation means what? Regulation of your heart rate. How is that happening? It is happening because of your neurons. Okay, neural control. So 1 and 2. Okay, what is happening? Here we have cardiac. Okay, cardiac accelerators. That means who will accelerate the reaction. And then we have cardiac inhibitors. 1 second. Cardiac inhibitors. Okay. Cardiac inhibitors. Are you all with me? No, it need not be. It could be because the valves are not functioning properly. Valves are not functioning properly. Okay, yes or no? Yes, got it? Clear or not? Yes, very good. Sympathetic and parasympathetic, right? Yes. Students, here what is going to happen? This is controlled by sympathetic nervous system. This is going to be controlled by parasympathetic nervous system. This is going to be controlled by parasympathetic nervous system. Okay, parasympathetic nervous system. So sympathetic nervous system, your adrenaline. Okay, here who will be there? Acetylcholine. That means your this one, students, neurotransmitter. Okay, acetylcholine. Okay, again thyroxine also will help. Thyroxine also will help. Okay, noradrenaline. Students, remember this is your fright situation. That means you saw the answer script and you don't know what is happening. Okay. You don't know what is happening and you're like, oh my god, heart is beating duk 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 duk. That duk 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 is because of your cardiac accelerator. That means your adrenaline is getting released, telling that this person is scared, this fellow didn't study anything, this girl didn't study anything when they were teaching. Now they are getting heart attack. Right? Right? Yes. Yes, Basava Raju. I've been taking continuously for 4.5 hours. Hardly 10 minutes break. Right? I don't know what's going to happen to my throat, but class is important. Yeah. I will take this class once again on the board, students. Like not now, later. Now you know the concepts. No, now concept wise, I don't need to need your help. But board wise, I will write a good notes and send it to you. Okay. Yes, we will definitely take the class on the board because you people like to see me with the board. But this is also not bad. No, only thing writing is little slow. That will take some time, right? Do you like this system also? Yes. Students, now we have only this one. Okay. Okay, students, come. Let's understand the diseases. What are the diseases? So I have put the slides for it. So I will try to make you understand. See, coronary artery disease or the CAD disease. That means, students, it is also known as arthrosclerosis. Okay, this is a very confusing topic. Okay, arthrosclerosis. It is caused by the buildup of plaque like calcium, fat, and fibrous tissue. That means when a person is consuming a lot of fat, okay, they're consuming a lot of non-veg or they're consuming a lot of burger, pizza, cheese every day, then that person's right valves, right, will get filled with plaque. Okay, that kind of a condition is called CAD. CAD. Okay, makes the lumen of the arteries narrower. Now, what is happening if the lumen of the artery is already narrow, right? If it becomes more narrow, it's become more narrow because full fat has been accumulated, then the blood pressure is going to be high. The blood will try to move as much as possible. Okay, right? The blood is going to move as much as possible. Yes or no? Yes or no? Yes. Clear or not, students? Is it clear or is there any doubt? Doubt? No, right? Yes. Pressure increases, right? Pressure increases. This pressure will allow what happening? This pressure will allow problems, right? This pressure will make the person's heart beat faster, right? This will make the person's heart beat faster. Okay, affects the supply of blood to the heart muscles. Affects the supply of blood to the heart muscles. Okay, clear or not? Clear or not? Now next one, let's see. Angina pectoris. Okay, angina pectoris might sound like a girl's name, but it's not. It is a heart disease. Okay, also known as angina pectoris. Not enough oxygen reaching the heart muscles. What is happening, students? The heart muscles are not getting enough oxygen, right? Your coronary artery, everything bringing blood is not able to supply enough heart muscles. So that is going to lead to acute chest pain and can occur both in men and women. Suddenly, have you seen people having a sudden chest pain, right? So it is a normal chest pain. Okay, chest pain. It means lack of oxygen. Some people get this when they're underwater, when they're in the flight and all, no, because of difference in the altitude, they might get a sudden chest pain, but once they're out, they might be normal. That could be because the oxygen is not circulating everywhere. Okay, yes. Next one, students, myocardial infarction, cardiac arrest. Okay, myocardial infarction. This is also known, this is what happens, students. The plaques will rupture and causes a blockage. That means, so this is your blood vessels, right? This is your blood vessels. Yes, 1 second. Yes, so look here, students. This is the blood vessels. Okay. Yes. Here, imagine the plaques will start forming blockage. Can you see? It will start forming blockage. Yes or no? Okay. So, this kind of blockage will actually again cause the problem. Okay. It can damage or death of the cardiac muscle tissues. It will cause death of the cardiac muscle tissues. Students, plaque means accumulation of this. See, students, have you seen on the teeth? Teeth, have you seen this yellow color marks coming? Yellow color marks coming when you don't brush properly. There is yellow color accumulation coming, right? That is called as plaque. That means accumulation of something, and then when it gets solidified, it will cause severe pain. Okay, same way, plaque means just accumulation of that fat, calcium and all that. Okay, calcium makes that look a little yellowish in color. So look here, coronary artery disease, plaque buildup in the artery. Okay, angina pectoris, it is harder for the blood to get through the artery because of the reduction in the size of the artery. Heart attack, plaque cracks and the blood clot blocks. That means what is happening? The plaque will rupture. Okay, it will rupture and it will get settled in the middle. So what is going to happen? It will, like this, it's coming, it will rupture and it might form like one blockage in the middle. Now it will not allow the difference. It will not allow the blood to move. Okay, got it? Got it? Clear or not? Yes. Not seeing the chats moving. Okay. Heart attack and heart stroke does not have that much difference. It's the same problem. That means where there is interruption to the flow of blood, and also there is lack of oxygen. Lack of oxygen. Same reason only. There's no much reason. Sometimes heart attack can lead to a person's death very soon. Heart stroke is where the person falls and then they get to know that there is a blockage and maybe there is a way to get, okay, right. That will be done. So otherwise, similar. Very similar. Okay, very similar. Students, are we done? Are we done with the chapter? Yes or no? Yes or no? Okay, sometimes what happens, students, when a person has heart attack, no, they give they give sudden medicines like anticoagulants. Okay, to anticoagulants will be given, beta blockers will be given. Beta blockers are very common. Okay, suddenly, like when you go with the heart pain, right? Suddenly, if you go, they will give this, or they will give you ASC inhibitors, like just to make sure. After that, if they do angiogram and all that, and they will get to know that this person has blockage. Okay, and they will understand, okay, something has to be done, right? Something has to be done. We have to do a bypass surgery and remove the blocks. At sometimes even it can be later stage. Okay, cardiac arrest is an immediate, like in the sense, if a person have cardiac arrest, that means that person dies on spot. Heart attack is more of a delay. That means if say two arteries are blocked, okay, or two veins are blocked, that is coming to the heart, then a person might have heart attack, and then they will get to know, okay, two blockage has happened, let's remove the two blockage. But when cardiac arrest happened, what happens? Sudden the person collapse. Clear? Yes or no? Clear or not? Is there any doubt so far? No doubts, I hope. We have done with the chapter. Yes, easy or difficult? Easy or difficult? Let me know. Is it easy? Did it become easy, or did it become difficult? Easy? Yes. Okay. Yes. All of you tell me in the chat box, how did you feel about the class? All of you tell me in the chat box, how did you feel about the class? Yes? Tell me quickly. Done and dusted. Okay. Yes. So students, you should tell heart made easy. Heart made easy in the comments. Okay, that is the word for today. Okay, what will you tell? Heart made easy. We have one more slide, students. Okay, heart made easy with the heart. Okay, heart made easy. Got it? Done? Okay, students, one small difference I'll tell you. Atherosclerosis and arteriosclerosis. Atherosclerosis means there is a plaque formation. Okay, and atherosclerosis means thickening of the inner wall, because of which there is lot of pressure that has to be exerted. Clear or not? Here, plaque formation, you can see here what is happening. Thickening is happening. Okay. Clear? Yes or no? Clear or not? Yes. Okay. Yes. Heart made easy should be your comments. How many comments am I expecting? How many comments am I expecting? I'm expecting 30 comments. More than 30 comments. Okay, heart made easy. Students, today we had lot of struggle. We had spammers. We didn't have board. We had this pen. So we had so many issues. Still, we made complete the chapter. That is how it should be. We should have the dedication to complete, no matter how many problems come in our way. Life is full of problems. We should go along with the problems, right? Go with the flow, right? We should be like cascade reaction, one after the other. Yes, 50 comments. Okay, let's see if we'll get 50 comments or not. If we get 50 comments, we will trust Laharika. Okay, students, so I hope all of you have joined our victory mock test. Students, victory. Okay, victory means only winning, right? So victory mock test, you have 5 full length, 5 part syllabus. Okay, tomorrow test is going to happen at 2 p.m. Okay, tomorrow's test is going to happen. Our regular Super 6 series test is going to happen. Okay. Yes. And full length paper based on the latest syllabus. You will have chemical coordination and this chapter tomorrow for my test. Okay, chemical coordination and body fluids is my syllabus. Okay, now you already know the chapter. Revise it before 2 p.m. tomorrow. You do not have any class, I believe. No, sir's class is there. But you can revise it before. Students, read NCERT. Do not forget to read NCERT. Yes or no? Do not forget to read NCERT. Are we clear? Are we clear with that? Yes, okay. Students, and also you will get your complete paper solution. You will also get your All India rank and your performance analysis report. Performance analysis report. The exam will start at 2. Exam will start at 2 p.m. sharp till 5:30. If you join late, then you will not get the rank. You will not get this ARF. Instead, you will be able to get your other two things, paper and this one. Marks and this one you will get, but you will not get your rank compared to other people. Yes or no? So students, how to enroll? You click on buy now, then you don't have to pay any money. The link is in the description box. Just go to the description box. I cannot bring the screen here. Go to the description box, click on the link, enter your phone number or your email ID. In case you don't have a phone, enter your email ID. You will get an OTP. After you type the OTP, you have to proceed to pay, and you'll only have to pay 0 rupees. Okay, up to when? 28 Jan 11:59. After that, you will have to pay 3,999. Okay, so do you want to pay money? No, right? Heart failure, heart stops beating. Yes, that means that lub-dub, the cardiac cycle gets disturbed. And in cardiac arrest, yeah, if the muscles completely stop, that's the reason why the person will not be able to, like, it's fatal. It is fatal. Right? Yeah, even I'm hungry. Let's finish the class. So see you all, students. Thank you so much for joining. And do subscribe to the channel if you have not subscribed to our channel. And do let me know. And you know what is the caption we are putting? Heart made easy. Okay, heart made easy by whom? By Gopika ma'am. Okay, heart made easy by Gopika ma'am should be your comments today. Only this comment I expect. Okay, heart made easy, because heart is a very complex chapter, students, and not every teacher can, like, it's very difficult to put it across. Like, even when I was learning, it's very difficult. Okay, yes, thank you so much for joining. See you all. Go have dinner. I'm sorry for not giving you enough breaks, but breaks make us less people and make you people lazy. So yes, do not forget to enroll. And yes, thank you, students. Bye. Do not put it here, put it in the comments after the session ends.